Greetings, everyone. This is Chris Freely, September 13th, 2018, and this is my presentation on expansion theory science, an overview of the new physics based on the 2004 book, The Final Theory by Mark McCutcheon, with interpretations by Chris Freely, that's me, using the accelerated expansion theory model, which is my particular model of expansion theory. Here we go. All diagrams or tables used in this educational presentation are scans of images in The Final Theory, the book by Mark McCutcheon, unless stated otherwise. What is expansion theory? A physics theory originally promulgated by Mark McCutcheon in his 2004 book, The Final Theory. Mark attempted to address the issue of what creates the four forces of nature as understood by the standard paradigm of physics that underlies the standard theory of quantum physics, which is called the Standard Model. Using a logical approach, Mark demonstrates that the four forces of nature are in fact based on a single force that is easy to understand and logically follows from known observations of physics. Using multiple examples, Mark attempts to prove that his thesis is superior to the existing model of physics, which he does. We will examine here the implications of those ideas and new interpretations based on my work with expansion theory physics. The primary premise of expansion theory is that all matter is made up of a single basic particle, the electron. The electron is a sphere, and the electron is expanding into the space around it. That expansion creates the four forces that are described in modern physics and the Standard Model. The single force, expansion, explains the other four forces. Gravity is no longer a force that pulls objects together as in standard physics, but is instead caused by the expansion of large objects into the space around them, which is based in Mark's concept on the expansion of the atom, which is based on the expansion of the electron, of which atoms are made of. That expansion is estimated to double the size of anything that is made of atoms, including an atom, in about 19 minutes. That is the doubling of the volume of the atom. The strong force is replaced by the expansion of the nucleus, which is made of protons and neutrons, which themselves are made of large numbers of expanding electrons. Depending on which model you are looking at, that large number is either hundreds to thousands in Mark's concept, or in my mathematical guesstimates, approximately something to the order of 10 to the 23rd electrons per proton, which is a vast, vast number. What is expansion theory continued? The weak force is explained in Mark's original theory with the idea that if atoms made of electrons lose their outer electron shell, they automatically expand in the space around them as light, to be explained shortly. That's one of Mark's core concepts around which a lot of my arguments are going to be directed against, to limit some of what that idea represents, because I don't necessarily agree with it in the way that he has written of it, and it's possibly not totally true as well. But it's definitely worth a conversation about. In my alternative, the weak force is replaced by pressurized motion contained in the nucleus due to the structural makeup of the nucleus, but which is still supported by the underlying expansion of the electron. Also, there would be explanations of this, but essentially the idea is that in the nucleus, the structure of the way the nucleus is made up can hold together pressurized structures, much like you would expect a gas cylinder to be pressurized particles inside a container, or something like a spring, by which when you release the pressure, suddenly there is a massive amount of force released. And I will also continue talking about that later in the presentation. Electromagnetism as a force is stripped of the concept of charge. Charge does not exist in the new model. This is something that Mark insisted upon, and I happen to agree with him completely. Electromagnetic processes are the processes created by rivers of electrons in motion, backed by pressure internal to the systems they make up. Think of a circuit. Think of a flow in terms of the energy inside a circuit being the river of electrons that is being moved forward along that circuit. And then you start getting closer and closer to what's actually going on down there. Light is also made up of electrons in this model, so it's clearly a form of mass in motion. Light is in particular made of electron clusters, which we will talk about shortly, and it makes light into a form of mass, in fact, as I just said. Mark's book has many in-depth examples that demonstrate that gravity cannot be a force that holds together the universe through pulling objects towards a gravitational center as the gravitational field is believed to act. Mark completely dissects and debunks Newton's laws of gravitation, where he's attempting to say that two objects are held together in a gravitational field. Mark demonstrates that Newton's proofs are in fact essentially assumptions that are never mathematically proved, built into equations. In a similar way, Mark goes after Einstein with his E equals mc squared equation and demonstrates clearly that Einstein cheated in his equation through the mathematical proof, whereby he omitted a line which showed that c in the equation, when he was deriving it through derivative processes, which are familiar to anyone who studied calculus, he took c down to 0 and then reinserted it. But then he omitted the line where c went to 0 and where he inserted it. And Mark went through line by line and found this omission, and he couldn't find the proof, and he figured out what had happened. And that's egregious because nobody even noticed this for 100 years plus, that Einstein lied. Einstein cheated. And his E equals mc squared is not proof of any type of limit on the speed of light whatsoever, even though light does appear to still move at the speed of light from a point of emanation. It eliminates Einstein's proof that no mass can go faster than the speed of light, which will become very important the more we analyze the theory. Okay, so the most egregious example of the failure of gravity to work as a force which pulls things together is the one of geosynchronous orbits, specifically a geostationary orbit, where an object moving at a particular speed can remain directly above your head essentially forever without being pulled down by the apparently missing gravitational force, and this is done at a particular height above the Earth. This example alone is sufficient proof against the erroneous notion of force-pull-based gravity, because the object's sitting right above you. There's no force holding it up from, it essentially firing a rocket towards where the gravitational force is supposed to come from, and that gravity, what we know as the acceleration of gravity, somehow is missing. It's missing in action with that particular example, and it's so egregious and so obvious that it completely disproves the gravitational theory with just that simple example. Gravity and charge both have a mysterious power source that allows them in theory to exert an attraction without having to account for the loss of energy from somewhere. This is one of Mark's major points in his book. This is never addressed in the standard model in any logical way. And this is a fact. Quantum physicists cannot explain this stuff because they don't really believe in energy as we know it, and they just sort of ignore the issues that have been so egregious for many years regarding the weirdness of quantum physics, which I will get to. There are many slides about the weirdness of quantum physics to come. Read Mark's book, The Final Theory. He has many examples, which I haven't included here, which prove, especially with gravity and his contentions against quantum physics and the Big Bang, those are vital reading, as well as his descriptions of light and his descriptions of the atom. And I'm going to show you some slides with some of those examples shortly. But his book has even more examples, which I can't list, and hope to have this video be under like 2 or 3 hours, because it's a huge amount of material. His book is so well thought out and so well written that literally he thought of a lot of ideas, and I can see why he stopped where he did, because what I'm going to add on top of this is going to be a lot to digest. If you read his book and then watch this presentation or read my core essay, it's a massive amount to digest because we're moving into a totally new science here. And it's totally proven, and I continue to prove it every day with videos and with writings. So I wish to address the results of the proofs that he presents, Mark presents, in order to redefine our current scientific thinking, as well as to address several issues I believe he fails to address, as well as to question a few of his assumptions with several issues they bring up. What is not in doubt between me and Mark is that the expansion of the electron is the basis of all matter and all motion in the physical 3D universe. This is not in doubt whatsoever. This is the cornerstone of either version of expansion theory, is that the electron's expanding, it's the basis of all matter and the basis of all motion ultimately in the physical 3D universe. Is what? Understanding the new physics. We're going to start getting into some of my contentions here specific to what's really going on in the subatomic world and in the atomic world as well. Understanding physics is, in the new model, comes down to understanding the relationship between the expanding electron, now the basic unit of mass, and the rest of our physical observations. And I'm going to also redefine mass shortly to be a property of the electron, but for fundamental reasons, the electron is really the fundamental unit of mass. And even though mass could be considered a property of the electron, as well as the concept of vibration or vector motion, which we will get into here shortly, I consider those properties of the electron, but I still fundamentally believe that the electron is the basic unit of mass in the physical universe. So that's going to might get a little confusing for some of you, but if you can hold several thoughts simultaneously in your head, it shouldn't be that hard. So there are currently 3 versions of expansion theory: mine, Mark, and Roland Michel Tremblay, who I talked to before I made this presentation, and I watched his videos that he made, interviews on YouTube. If you look up expansion theory and Mark McCutcheon and the final theory on YouTube, you'll find his videos and probably some of mine as well. He does interviews, and he actually understands Mark's book. He's got it better committed to memory than I do because I've been working on my own theories. So I had to go over a lot of what we talked about. I talked with him for 3 hours after I saw his video, and so we talked, and it was neat. Anyway, so and I will primarily focus on Mark and mine's with occasional mention of Roland's, which you can read more about on themarginal.com, which is Roland's website. And Roland has some unique ideas which are different from the other 2 concepts, because he goes into the idea of essentially micro, his version of the atom, for instance, is as a galaxy, and his version of the electron is as a solar system built off what he calls neutrinos. So that's his concept, and I'm going to not mention his concept as much because I want to focus on the fundamentals of expansion theory as Mark introduced it and what I had worked on outside of Roland's version of things. Obviously, there's a lot to debate about if we ever get into conversation about that. So we're going to move on just between the main debate between me and Mark. I don't want to add a third debate in here because it'd get too complicated. The core essay on chrisfreely.com, which is my main essay, or chrisfreely.blogspot.com, which is my backup website, is my main essay on expansion theory and its cosmological and physical implications. And read it, basically. Most of the points made in this presentation are in there. There's a few new points that I haven't addressed before that are in this presentation that add to the arguments on that core essay. And this presentation is more final in terms of the way I see things. The core essay introduces a lot of the ideas I'm going to present here, and it doesn't necessarily say, well, this is the right answer. These are what I say are the right answers when I go into a hypothetical question on my core essay where I say, well, here are the possibilities. So out of those, I picked final conclusions in the way I see things. So this presentation is about those. It was made before I made the final conclusions to my analysis, though it is all in the essay in its hypothetical form, with the exception of a few points I make about quantum physics. Just before I decided between a few points I made as hypothetical options in the new essay. There are 4 additional shorter essays linked at the bottom of that essay, which actually work their way towards the conclusions I'm presenting here. What is what? Again, understanding new physics. As I understand it, and this is basic analysis of observation for all of physics, physics is based on the 4 properties of mass through expansion pressure, which is the electron, motion expanding with expansion pressure through space, which is what we call vector motion, and objects moving, and time derived from the unified transformation of both space and matter through a holistic field of some kind. That is my concept of time. Mark has a different concept, but my concept of time is that time is essentially behind all motion, and that it is probably part of some sort of holistic field, which is outside what I wish to address right this instant in this presentation. But time exists, and to me, I believe time is the basis of other properties of the cosmos. And it's not something that can be denied, which of course a lot of people try, but it's kind of irrelevant what they say when they deny it. So anyway, that is basically the core argument of, okay, well, what's real? What's there? You know, for an easy way to look at things, this is the easy way to look at things, 3 fundamental properties that you look at. And the motion is kind of a 4th property. So really 4 properties, but we just look at those and we say these are real. And Mark does this differently, but this is how I saw it. As such, we all know from physics that the basic unit of matter is the kilogram, and it is actually derived from an exact number of electrons which make it up. The basic new unit should be the electron ideally. However, we will stick with the kilogram for now, for convenience. Basic unit of space, the meter, will remain in use in my analysis. The basic unit of time, the second, will remain in use in my analysis. Again, this is slightly different than what Mark says, though he seems to agree with me about time being the basis of a lot of stuff. And we'll get into his concepts as we move on here. Just want to make sure before I click onwards. All right, that's just a slight error with that. Which makes it up. It's supposed to say which makes it up. Remaking this constantly. Why the 4 properties? And this is, you know, basically it's a philosophical question. Or material philosophy for dummies. Real quick, people. This is like just the way things are. These 4 properties of physics cannot be denied in any realistic analysis. And this is one of my core arguments. When I get into my version of expansion theory. Time exists. Its existence cannot be denied because everything happens in time. Duh. This one is mostly a duh, but there are some of those people out there who love to deny it. Well, time's not real. It's just a figment of your imagination. Try that in the real world. It doesn't work. But anyway, some people are hopeless. They're there. I'd like to just move past them. Please, those of you with a little bit of common sense, follow me, and I shall make you fishers of non-idiots. Matter exists without a question, so duh, right? Okay. This should clear out all the idiots, like really easy, okay? Can you handle the idea of matter? No, it's all just fiction. We're living in a matrix. I'm going to jump off this bridge now and Wrong answer. Please do not ever ask anyone to prove the existence of matter to you, because they will hit you over the head with a plank. Seriously. Anyway, would you like to see my proof? Space exists everywhere. We see it, even if it appears to just be emptiness between objects made of expanding electrons. Right? Right? Space? Does anyone doubt space? I've never heard that one before, but I'm sure it's out there somewhere. No, it's all illusion, and this world's not real, and I'm in fact really a trans-dimensional being living in a higher state of consciousness far beyond you primitive mortals. Space exists, deal with it. Hence, distance is real, and this has some fundamental effects that we will examine shortly. You may ask, well, why do I need to prove this? Because Mark has some issues with the distance between things because of his idea of the meter and his idea that the meter is in fact made of derived measurements in the atomic realm. And so he says, well, the electron doesn't have a space that it takes up. It doesn't have a measurement that we can know. And I don't agree with him about this. And this is going to create some real consternation down the line for expansion theory believers. There's going to be a big argument about, well, is space real? Is the meter a real function of measurement? And my God, people, try to live without it. Try to live without it. It doesn't completely jive some of Mark's extended ideas about the universe once you get past the expansion concepts, his counter arguments against the Big Bang and the quantum, the standard model, and some of his other arguments, which I'm going to get into here. Though I love the man, he's great. He's great. He's a genius. He just missed a few things. Motion exists because matter moves through space by means of internal force. This is an idea of force as something that is moving these expanding electrons through space by force, and that's how you get them to go from point A to point B. And in between point A and point B, you don't see any changes in the amount of force that these electrons, which of course also applies to all objects since everything is made of them now, you don't see a reduction in force when you do physics measurements, as you would expect if some of Mark's concepts were valid, I think. Though it depends on some of the rates involved. But fundamentally, I still hold that, yeah, motion and energy and force and some of these properties that Mark wants to toss out the window and just focus on expansion can't be tossed out. This is the motion argument is what I call vector motion. And that's what it's called in physics analysis. When you take college courses on physics and you're trying to determine what happens when two objects strike each other, we deal with vectors, which are motion attached to objects made of mass, which have force attached to them. A particle in motion has a vector. This is like without a doubt. So next, so this is the material philosophy. You can understand these four concepts. You will have an easy time with this. This is Mark's new model of the atom, according to the final theory. That's his book again. So you take a look at this, and this basically gives you the idea. The nucleus, as you can see right there, is expanding because it's made of electrons, and these electrons are bouncing off the nucleus. So you know that electron cloud you know about in chemistry? Those are electrons that are bouncing off an expanding nucleus, and they're bouncing off of it because it's expanding at a much faster rate, relatively speaking, than any individual electron can. So anything that's made of a huge number of electrons expands at a much faster rate because it's all those expanding electrons are all clumped together. So you get a huge amount of force jumping out there, shoving these individual or smaller electron like a smaller subatomic electron clusters, essentially. These things we call electrons in physics. But point is that the electrons are being bounced off the nucleus as it expands while they expand simultaneously. And that bouncing is what's creating the atom. And by the way, I agree with this model for the most part. This particular element of it as in how it's drawn. Not necessarily what Mark's writing here about the space outside the electron and the space inside the electron, because he makes a massive distinction between the two. And I think there's less of a distinction if there's one at all. Okay, so the limits of bouncing electrons defines non-expanding atomic edge. Now that's one of his concepts, and again, that's the way he sees it. So we'll just run with this now. And atoms are made around the nucleus, which is protons and neutrons expanding into the space around them. The expansion causes electrons not in the nucleus in the form of protons and neutrons to bounce off the nucleus. Okay. That might be a little confusing for some of you, but basically the electrons are bouncing off the nucleus that's made of protons and neutrons. This bouncing produces the electron shells and clouds known in chemistry. I think we just covered that, but I had to reread it. Okay, And there's your little picture of what it looks like, sort of. Of course, that's a 2D picture. We're looking at a 3D sphere, but moving on. I agree with Mark's conclusion that the expanding protons, all made of huge numbers of electrons, expand into the inner atomic space. There is some debate, in my understanding, as to whether the neutrons contribute as much to this expansion due to the chemical properties of atoms being largely determined by the number of protons. We will return to the atomic model later to examine my contentions. So my basic argument is, okay, protons are also added with neutrons to determine the chemical properties of the atom. I think I'm kind of making some conclusions about this like right now after many years of thinking about it. But I'm thinking, well, maybe the neutron proton thing isn't really that important. Though when we look at, let's say, hydrogen, when you look at hydrogen, deuterium, and tritium, they do actually have more chemical differences than other isotopes because there's only one proton, and so that those neutrons have a disproportionately large effect on things compared to the larger atoms. So in many ways, what a proton and a neutron is less clear in the new model than what it was before, but they're basically both the same size and basically both the same mass, more or less, except for that other quote-unquote electron that gets erased from the proton to make the neutron. So, or gets added to the proton to make the neutron. I think the neutron is the heaviest particle in there, if I remember correctly, from my standard model education years ago. So yeah, essentially, we're going to return to this argument, but it's easy to understand that the nucleus is made of expanding protons and neutrons, and they're the ones that make the properties of the chemical elements. But we'll see the properties aren't technically as important to the biggest pictures when we get to those later on. Because that's mostly, literally, when you look at properties of elements, it's not as important for the cosmological dynamics as the properties of other things in the cosmos. But we're continuing on. This expansion of the nucleus explains both the strong force and the electron clouds that are currently considered to be waveforms that collapse upon observation by physicists. So, the expansion of the nucleus is what sort of holds the structure of the atom's chemical properties together, rather than it being the collapse of the waveforms as we understand in the quantum paradigm, whereby the model that is being replaced is the idea that you take a look at something that's a wave equation and it collapses, and we're tossing that idea out. The solid physical electrons bounce off the nucleus, creating the cloud of electrons that surround all atoms. The nucleus is so large relative to the tiny electrons that this bouncing creates the tremendous empty space we see in X-ray observations of the atom. So I just want to go over that, where the strong force comes into play with regards to the electrons around the nucleus. I suppose I might have put that in not quite perfectly, but it explains some of the electromagnetic properties of the atom apparently as well, because as we'll see shortly, I think the protons and neutrons expansion is also most of what's holding chemical bonds together as well. Bonds. So, major logical problems with the current quantum atomic model. Here I'm going to go a little further than Mark did. Mark just attacked Einstein and Newton. He didn't go into Heisenberg, Schrodinger, Dirac, and the quantum crew, as I like to call them. Now, these guys are great mathematicians. I'm not disrespecting their mathematical abilities, which exceed my own. Not that I couldn't understand their mathematical abilities, but my limit of math ended around calculus 2 or so. But you don't really need to understand that to understand the basic concepts of the new model. But let's go on to find what's wrong with these guys' theories. Heisenberg's uncertainty principle and Schrodinger's wave equation are the key underpinnings of the quantum model of the atom, which is pretty straightforward because they're the ones that are quoted most in terms of what work they did, mostly mathematically, to attempt to solve some major problems in physics as they encountered them. There is some additional contribution from Dirac's quantum algebra. Each of these three major underpinnings to the Standard Model fail logical tests as to how they are correctly interpreted. See, what we're dealing with now is the interpretations of the people who teach the Standard Model versus the logical inconsistencies not only internally within these ideas, just on philosophical grounds and physical grounds alone, but in addition, in contrast to the new model, which is very easy to understand, has a physical basis, and has mechanisms which explain it. Heisenberg's uncertainty principle claims that one cannot know both the location and the speed of any subatomic particle. The concept is said to validate the idea of the wave-particle duality of all of quantum physics, and is the cornerstone upon which the wave-particle equations of quantum physics are utilized in hypothetical scenarios. Yet this principle is also applied in all macroscopic relationships, because to take a measurement of any object in motion, one must take two measurements to know the speed of normal objects as well. This is just a fact. You can't take two measurements and pay attention to where something is at the same time. You have to take those two measurements, and then you can take what's called a point location, where they say, and you should know this from quantum physics, that you can't know the location and the speed of a particle at the same time. You can't know the location and speed of anything at the same time, because the process of taking a speed measurement requires you to take two measurements, during which time you're not looking at the position of that object, unless you're taking okay, I'm going to take the first measurement now, and I'm going to watch the object, and then I'm going to take the second measurement. But at some point, your eye has to be off the object to take a measurement. That's what Heisenberg's uncertainty principle says at the core. And you see how it can't really be applied from that idea to the reality that they claim, which proves that physical matter is not physical, but it is in the form of a wave, of which they don't really explain either, this non-physical wave that makes everything up. Heisenberg's principle of macroscopic analysis, which is the analysis that's macroscopic, not microscopic, is not used to justify the idea in normal understanding that a car is merely a massive waveform that collapses when observed. Except, well, for 90 to 99% of it, that's true. 90 to 99% of us use the law of common sense and say, well, yeah, that car is solid. But people in physics, I guess, or people who take this idea too seriously, say, oh, it's just a waveform. So anyway, don't try this at home, kids. If you know what I mean. I think I'll just stop this waveform with my hand. So common sense dictates that because one must take two measurements, which I just explained, the initial position of measurement and the final position of measurement, it does not follow that the car is not physical during the time one must take these measurements in order to determine the speed of the car. But that is exactly what quantum physicists allege about particles. Oh, they're not physical during the point that we took the first measurement and the second measurement. They could be anywhere in the wave equation. Oh, it's just a probability cloud. Have you ever seen numbers floating at you while you're walking around, unless you've been watching too much of The Matrix and have it jammed into your brain? No, the world isn't based upon those numbers. Those numbers are abstract. This is one of the big problems with quantum theory. It takes the reality of abstractness instead of the reality of physicality, and that's not real. That's complete fabrication, bullshit, unjustified assumption. And it can't be applied in the real world. Anyone who tries to apply this in the real world, you're going to try to walk through a car thinking it's a waveform, you'll be killed. So this idea is not Darwinistically sound. You can't apply it to the real world because it's not real. It doesn't work. So common sense violates that rule right there. They're misapplying Heisenberg's uncertainty principle, and they're getting away with it. I noticed this back in high school, long before Mark said anything. I was like, that shit don't make any sense. You can't live with that idea. So, but that's what quote unquote scientists teach, right? Bullshit. I call bullshit. As such, the uncertainty principle, through the current Copenhagen interpretation and many worlds interpretation, and Copenhagen is the main interpretation of quantum physics. The many worlds interpretation is that version of quantum physics that you hear that, you know, where something happens based upon the change in the probability cloud of the electron. There's multiple different parallel universes which exist simultaneously based on who observed the electron at what point. Which is also a completely idiotic concept, which I won't even get into here. But the Copenhagen interpretation is the mainstream interpretation, which does not believe that. Also a very common thing that a lot of people, lay people, don't know, that the Copenhagen interpretation still sticks to the idea that, yes, there's only one version of reality, and it's not based upon the observation of the electron. The subatomic particle, and it collapses from the wave equation. So continuing forwards, these interpretations of quantum physics using the uncertainty principle are a misapplication of the law of measurement of speed and position, which I just described a few minutes ago, when contending that particles are non-physical waveforms that collapse upon observation. These are merely assumptions that are never proven in any real-world science experiment. Please, those of you who are arguing against this position, if you ever choose to actually have an argument with these people, use that idea, the law of measurement of speed and position, because it's a law. I mean, it's a freaking physical law that they're violating, and they think nobody noticed, but there were a few of us who said, oh, wait a minute here. Y'all guys, I don't really know about this. You know, it's not like something I'm going to bank on. I'm not going to be all in on this Copenhagen many worlds interpretation of reality. It's just not a good bet. It's not a good bet. Let's move on, shall we? Okay, we're going to add some more ones that you guys are probably less familiar with, especially outside of physics. Similarly, Dirac's quantum algebra states that under certain conditions, A times B does not equal B times A. So what that means is he was attempting to figure out some elements of quantum physics and how to apply them. I think it had to do with matrix mechanics, and he was attempting to work out some concepts there, and I didn't understand completely what it is he was totally trying to work out. It's kind of irrelevant in some ways. I've only got so much time, and it's kind of a hard read, but essentially that's the basis of Dirac's quantum algebra, which is one of the three cornerstones of the Copenhagen model. So this is what I interpreted based upon what I read. And I'm not sure about this, but I'm on the right track. This can be seen as a systematic problem due with orbital motion, where positions vary and mathematical abstractions of distance and motion is constantly in a state of flux. So what I'm saying is, he was probably attempting to address the systematic problem of the fact that when you're measuring distance, that measurement's always going up. And so when you try to cross A and B, or B and A, when A and B are always changing, then you've got yourself a problem, because A and B are not in a state of constancy. So if you're taking a measurement at the beginning of something and at the end of something, like the way the quantum physics measurements are, A and B are going to change between the time you take measurement A and the time you take measurement B. This is a common problem, I think, when you're attempting to calculate variables in equations of physics, when you're dealing with multiple variables and multiple layers of what's actually happening in the physical universe. So I think that they're actually dealing with that problem, is that, oh yeah, A and B does not equal B times A, because A and B are always in a state of change. So anyway, like I said, this can be seen as a systematic problem, a problem of systemics. That should say not with, it should say due to orbital motion. I cannot believe that. Ugh. Anyway, due to orbital motion, where positions vary and mathematical abstraction of distance and motion is constantly in a state of flux, because that electron or that particle is always adding distance into wherever it's moving, and if you're taking a measurement, you're not adding that distance. So there's probably like things like that are going on. That's why there was this weirdness, and I don't know why they had to add this quantum algebra thing in for whatever reason. Maybe it was just another thing they had to pile on to confuse everyone. But if A and B are always changing, then indeed this is true mathematically. So yes, Dirac is correct if A and B are always changing, but this is only a mathematical ruse, because the actual position of any electron is present physically in the physical universe at an exact point at every single time. There's nothing mathematical about the point where the electron is when you're trying to abstract its position. The universe is not made of numbers, I should hope you know by now. It is made of physical vibrations that are not abstract at all. Quantum physics was constructed by mathematicians who did not understand the underlying non-mathematical properties of objects. This is very clear when you are observing what it is they are talking about. Schrodinger's flawed wave equation. I'm going to cut into Schrodinger here, even though he's mathematically a little beyond me. But just a little bit. Like, I could take a couple of weeks and I'd be right on his level, really easy. So this is like, they want to intimidate you. They want to say, you can't understand our complex, big mathematical equations. But actually, if you sit there and you study it, and you take a breath once in a while, it's actually all straightforward. So I didn't go through the extra steps, but I'm telling you, even the least of you can make a better proof than me of beating these guys, because they got a lot of holes in their equations and holes in their theories. Schrodinger, like all the quantum physicists, was a mathematical genius, without a doubt. He came to believe that all matter was not a particle at all, but a wave. That was just what he saw. He was like, nah, it can't be a particle, it's got to be a wave. He developed his famous wave equation, which I didn't show it here, but it's online. It's easy to find. In order to attempt to prove this mathematically, and perhaps the most famous of all the hypotheses of the quantum physics paradigm, with the exception of Einstein's theory of relativity. A lot of people know about the wave equation. This wave equation was then combined with Heisenberg's uncertainty principle, you know that guy, to give us the probability theory of electron clouds. That's where it comes from. And fundamental particles, also where it comes from. And that's what they built quantum physics on this. And another thing I will get to later in the presentation after I go back to expansion theory and flesh out some more ideas of how it actually works. Yet the entire effort resulted in the removal of anything physical from physics, which really causes problems. No longer could one rely on the idea that the world could be understood in the sense of classical mechanics, which did assume that physics was physical. And our new theory, of course, also assumes physics is physical, as in existing in 3D space made of what I call vibrations. The electron is a vibration, or wave, you could even say, in the physical universe. But it is physical. It's three-dimensional, and there's no way you're going to get through it with another electron, or possibly with anything, depending on how that structure actually works. So that is an overview of Schrodinger. So, to give Schrodinger a little philosophical credit, special topic is the new notion of the electron, a particle, or a wave. The electron is visualized in the new model as a sphere that is expanding in space. It is therefore a wave that is expanding in space. I like to call it vibration, but you can call it wave if you'd like. This does in fact agree with the spirit of Schrodinger's assumption that all matter was in fact in some way a wave, but not in the sense that Schrodinger believed. This wave expands continually and is effectively solid. That's a little different than what Schrodinger thought. This does not change its nature as a particle, though, as it moves in space with a vector motion. That's not Mark's version, that's mine. So also, it's a particle, but it's also moving through space with a vector motion attached to it. It's moving through space. When it strikes an object, it imparts an energy into those fields. It imparts a force on whatever it hits. It has a motion relative to other things. Mark is right. Mark says all motion is relative. I agree with him. Yes, two objects, what is their motion? You have to look at, well, what's their motion relative to each other? There's no real absolute motion unless you have something else to observe the motion external to that sphere. And that's kind of one of Mark's and I's philosophical musings. But it's accurate. It's accurate, but then relatively, as long as we assume things exist, then yes, everything has a vector motion fundamentally. And we know this from physics because, well, the proof is all in the physics. Go look through the evidence. It's everywhere. Thus, the electron can be thought of as a wave or vibration that expands in space and is effectively solid because it will resist any other wave or vibration that it encounters. Very important idea. That's why things don't pass through other things so easily, because the vibrations are pushing each other against each other. So that expansion, when you encounter another two electrons striking each other, they repel, quote unquote, but actually they bounce off each other. Excuse me. All right. So the question, is it a particle or a wave? It's both. It's both a particle and a wave. McCutcheon versus Freely, know the difference. You have to know the difference between my concept, excuse me, and Mark's concept. McCutcheon believes that the atomic expansion rate, which he calls x sub a, is much slower than the electron expansion rate, x sub s. Like he says, electrons are expanding at a much faster rate. And that's how he explains a lot of the phenomenon in physics. He believes that once electrons are outside the boundary of the atom, they begin to expand into the space at the much higher xs rate. That's like how he explains. He uses this property to explain electrical fields, static electricity, chemical properties, lightning, the energy behind light as an automatic without considering motion, and magnetic fields. Okay, this is Mark's position here. Mark says once you remove a nucleus from its electron cloud and you put it out there without an electron cloud, it will automatically, essentially, explode as light. It will return to light because he believes light is kind of like the natural state of the electron, so that when we see light, he doesn't consider it something that is in motion with the property of force or energy. He just says these are electron clusters that are expanding at that much faster inner rate. And he says that the atomic expansion rate is much slower than the electron's expansion rate. And his essential proof is, I think I did a slide on this, but in case I didn't, basically, as those electrons are bouncing off the nucleus, that top electron that's at the top, like at the very edge of the atomic boundary, or however many there are out there, the half of the electron is in what he calls the geometrical definition of the atom, and half is out. And that half that's outside the geometrical definition of the atom, as he calls it, that half that's out, its expansion into the space around it is what creates the atom. And so he says the electron's actually expanding at a much faster rate than the atom, because the atom's boundary, what it is actually only the outer half of that electron that's outside that boundary at the peak of its bounce, essentially. So because he said basically it stalls there for momentarily for like a microsecond, before it resumes its well, it wouldn't resume its fall. I assume before it falls back into the atomic realm. It's kind of a complicated idea to wrap your head around at times, but that's his concept. Because again, he says that that's non-expansionary. You saw in his in that the atom slide I showed earlier, basically that since it stalls there for just an instant, that outer half that's outside expands into the space around it. And he says, well, that's what creates the atom, and that the electrons inside are expanding at this much higher XS rate. So I think that he might have something to that. I just don't think the rate is as great a difference as he thinks. Like, for instance, I could say, well, okay, maybe it's expanding at double the rate because half the electrons outside and half the electrons inside the definition of the atom. So I'm like, okay, well, I'm not convinced of that argument, or whatever he said. But if there is a difference, there is a difference that is much less than McCutcheon likely believes. That's my position on it. So that's one of the major differences. Okay, so McCutcheon describes the atomic expansion into space as being the result of the most outer electrons in the electron cloud around an atom being half inside and half outside the atom. Because these outer electrons' outer half is outside the geometrical boundary of the atom, they expand outside the inner expansion. Create the inner expansion, which is the electrons expansion, which governs the subatomic realm, creating the boundary of all atomic matter through atoms. However, if he is correct, it would explain the behavior of electrical and magnetic fields in terms of the way they occupy space around objects. So like his argument is essentially, well, static electron clouds seem to expand greatly beyond the atomic realm around objects, and electrical fields and magnetic fields seem to be relatively huge around objects. But there's an alternative explanation which I came up with, which essentially is, well, there could be magnetic fields could be projected by the internal force of the magnetic fields, and they could just be forced forwards by the massive chain of electrons that make up magnetic fields, which are also made of electrons in this expansion theory. So, okay, so I saw that, and then what about this? Well, then his remaining argument is, well, what about the static electron bubbles, and what about light? I'm going to get into light, But like the static electron, I mean, they expand beyond where the atoms are, but they don't expand massively beyond where the atoms are. I think it could be easily just explained by a bunch of electrons just being shoved outside the nucleus. And if there's a difference between the two rates, it's minimal. And actually, if you look at all the evidence, I think I'm right again. Maybe I'm wrong somewhere, but I just don't see this huge supermassive internal expansion of the electron being just massively greater than the atomic realm. And I'm going to add more and more concepts to present the case as to why I'm not throwing out a lot of conventional physics except for a lot of the quantum stuff, the standard model quantum theories. My position is that while he may be correct, I could not fully understand the necessity of the idea, as the model I developed doesn't require the vast differences between due to expansion pressures. This is Mark's diagram of static electrical clouds around objects. Here you will see, let's see here. Here you will see the way he does this right here. These electrons that I just circled, they are essentially expanding the way he sees it. He sees essentially that these electrons here, these big ones, they're all expanding at the same rate internally, right? But then in the atomic realm, the ones that are furthest out, like in these big clouds, are actually occupying a lot of atomic space, is how he sees it. So this, atomic space, which is the space outside the atom, is essentially the space as we know it. And he says the space inside the atom is totally not the space that we know it. I'm going to read my little things I wrote here. The electron pictured here is the way Mark visualizes the effect of the expansion of the electron in the space in the realm outside the boundary of the atom. Because of the underlying much higher expansion rate of the electron relative to the atom, in this idea, the relative sizes of electrons in the atomic realm can vary as shown. So literally, yeah, he sees the static electron clouds around objects as looking like this, essentially, where these big electrons on the outside, they're in the subatomic world, they're going to be the same size. But in the atomic world, the way he sees that they're going to expand outwards in some fashion where they take up more space volumetrically than the other smaller, what appears to be smaller electrons closer in. And so he sees this as what explains magnetic fields and static electric fields, as well as, he didn't really go too much into chemical properties, but I assume that he also sees atoms and the chemical clouds around atoms, the electron clouds around atoms, to be of a similar mechanism by which they interact. Essentially, when the two contact each other, what he says happens is that those electrons in I think it's the less dense cloud, basically the two clouds shrink to a similar size, and whichever cloud goes into the atom first, basically it's shoved inwards as they resize themselves, then that's where there's a bunch of light and heat that gets basically shoved outwards by the expanding atom, essentially, I think is roughly how he saw it. Or maybe the spark is just the explosion of electrons that they have nowhere to go, and they're just shoved out, and automatically, the minute those electrons are severed from their clouds, they automatically turn into light, and the expansion, in his opinion, is what creates the light. Not in my version, but that is essentially the overview. So Mark versus Freely, know the difference. Some more. Mark believes that the expansion of the electron eliminates the need for the idea of energy in the universe, except in terms of the expansion of the electron. And that is basically the way he sees it. It's all just expansion, one form of expansion, another form of expansion. He doesn't deny space fully, but at the same time, he's very much focused on the idea that the expansion pressure just moves that stuff around, and it doesn't seem to mean very much in how he originally came up with it, in terms of like what doesn't mean anything for him is motion, where, like I said, I put motion at the center of a lot of the arguments here, beside the expansion. I lost this recording, this part of the recording actually, so I'm trying to re-record it. But essentially, I was going to talk about force in this, because I was talking about force in the recording I had to delete. But essentially, like force, energy, those properties are properties of the system. and they're properties of the system of the electron and physics, and they're part of a property of the collective expression of the events in physics, which primarily consist of impacts between electrons. So when an electron strikes another electron, that's when you deal with force and energy. They kind of exist hypothetically in this potential energy theory, but again, sticking with some of Mark's ideas on this, the conservation of vector motion, which I'm about to talk about here, has to do with when force and energy are real in terms of what effects they create in this new model. So they're present and they can be measured, but they're hypothetical until two objects, two electrons, and objects here includes magnetic fields, touch, having physical contact with objects. Until those physical contacts are real, then fundamentally nothing is happening. You understand? Like there's no energy and force until something happens along those lines. So I contend that expansion of electron, I contend that the expansion of the electron preserves the standard idea of motion, because any motion imparted to electrons by the impact of other electrons is concerned by the very expansion of the electron in such a way that both the physical electron and the force of a change in vector motion is preserved. Hope you can follow all that. The property that allows this to occur is mass itself, as mass is the carrier of motion, or what is often understood as force. Expansion, in my understanding, expands both, in other words, both motion and the definition of the electron itself. Expansion, in my understanding, expands both because they are exactly the same thing, vibration. This expanding electron is a vibration. It's not concrete, it's a vibration. Even though technically concrete's a vibration under that idea too. But you understand roughly what I'm saying. The electron is simply a 3D vibration in space. The underlying expansion conserves any external vibration imparted through the conservation of vector motion, by which outside force, outside motion, outside the electron is conserved. So if you impart, inertia into an electron, all that inertia is conserved, which is why we don't see the diminishment of energy in a object that is in motion in the physical. Like when one object imparts motion onto another object, by that process, we don't see any decrease in that when the object strikes the next object. That motion is preserved, and it's preserved exactly by the expansion, because it's all one vibration. It's all one vibration. The electron's there, but it's also fundamentally a vibration. So that's going to be important as we go forward, and I think it's really a fundamental cornerstone of how my model differs from Mark's model. What happened to force? We have to ask ourselves, in light of the new theory, what is the meaning of all the traditional concepts of fundamental physics, as distinguished from quantum physics? I don't throw away the fundamental physics constants of the universe with my version of expansion theory. I ask myself, what do they represent inside that system? What does it represent inside the system of transformation of motion by the observations that we see? When these impacts happen, when the billiard balls, as the electrons hit each other, where does energy go? Where does the force go? Where are they? What happened to force? Because I'm not tossing away the idea of inertia or force in the properties of my model. So certain physical ideas cannot simply be discarded the way Mark wants to do, I think, as we observe them in our day-to-day lives and have heaps of evidence for them that are easy to replicate and confirm. Force is one of those ideas. The easiest way to understand force, just as all the fundamental ideas of physics, is to look at the basic SI units of it. Look at the basic SI units of it. Not just force, all of them. Go through them. If you guys want to think your way through this, look at those units. They all have proof right there of whatever is happening. It's not that hard to figure out. So I'm going to explain this real quick. A force is expressed as kilogram meters over second squared, clearly showing the expanding electron, the kilogram derived unit, the unit of extra electron, quote unquote, outside the electron space, meter, as Mark defines it, and the acceleration upon impact with another electron object made of electrons. It's an acceleration because it's s squared. And because I had to do this slide over, the next slide is going to cover some of the rest of that. But it's important to kind of understand that whenever you see an object that's some denomination of something in a constant that's squared, you're dealing with something that revolves around after an event. See, before an event, kilograms, meters per second, the minute it strikes something, that's when force comes into play. Otherwise, there's no such thing as force in terms of the internal dynamics of the system, because then you're just dealing with motion, even though motion is also relative. But everything is something, and all of those things mean something, and you just have to think your way through them. So that's just my take. Accidentally clicked it on there. It won't let me go back, and I can't redo it. So that was just force, and force is made of those basic properties, kilogram, meters, and seconds. And again, kilogram meters per second squared is the Newton, which is the basic unit of force. And it's really sad that I just clicked on that thing. But anyway, because that was a very important point I was trying to make about the material philosophy of the new system, is that second squared, when you see seconds, kilogram meters per second is inertia. But the minute you add that second down there, it becomes kilogram meters per second squared. That's really important philosophically to understand what that means. It actually means, well, that second that's added to the bottom is an acceleration. That means when an acceleration only happens mathematically in these physics constants if there is a contact with something else. So there is an exchange of what? Time, because that's what is added. So force is inertia over time applied against another object. That acceleration is indicated by the basic unit. And I fundamentally believe that like basic units have to be dissolved down to their fundamental philosophical principles in order to really understand what they are, and then you understand physics. It's only when you can apply it philosophically to the internal concept of what mass and matter are doing that you really can say, yes, I have an understanding of physics. So I do that with all the fundamental constants in my own mind, so I'm very clear about what they represent. That's how I got the idea, in fact, that mass was a resistant property of matter, which we have right here in this slide here. What does that mean? What does all this mean? I interpret this to mean that force still exists and that the presence of the electron and its expansion in space didn't change anything for anything outside the electron in terms of the initial position of any electron relative to any other electron, to be explained shortly. There's like a dynamic that's going on that's kind of complicated, but I came up with a way of visualizing it so people can kind of understand where I am coming from. Granted that really, if we think about the new ideas that space and time are really the only thing that is actually outside the electron, that's basically the case. But the motion of objects in the real world don't confirm that motion is warped by the expansion of the electron in terms of the amount of energy that is transformed, just as I was explaining before, when two objects down to the smallest scale of 2 electrons impact one another. That's when we have energy. Energy doesn't exist until 2 objects strike each other. There's no such thing as potential energy. It's an abstract. It's just the potential energy is an abstract measurement. No energy is ever exchanged unless 2 objects impact and exchange their vector motions. This is because of several properties of the electron itself, one of which is expansion and the other of which is the electron's existence to other electrons. Very important idea. So one property of electrons is expansion and the other property is resistance. What resistance? The resistance that happens when 2 electrons collide. Collisions prove the property of mass. Mass equals resistance. This idea is one of the fundamental cores of my philosophical notion of what matter is. And it's different from Marx because Marx didn't go into this level of analysis as to what is what. So it's really important. What is mass? Mass is the resistance of objects to the passage of vibration. It is that resistance that actually creates the transformation of vibration we call energy. When two billiard balls hit each other and they exchange their vector motions, one going one way and the other changing its motion to be exactly like the one that it hit. You know, when you hit one that's still with a billiard ball, I mean, you hit a still one, the one that you hit, it stops and the other one goes. And the same thing for basically any type of motion that the object that strikes the other object, there's a transformation that happens when that happens. And that's happening because mass is resistant to that. But mass's resistance is actually what allows it to be carried along with the motion. See, like that's how you look at it. You got to see, well, there's this other vibration, motion, that is dragging mass along with it as a force, and that doesn't change. And that actually is conserved by the expansion of the electron because the electron's expanding the mass. So the inertia that we measure in physics is actually real in my model. Marx says, no, it doesn't exist. Nothing exists except the expansion is just geometric. And I say, no, there's still a property of motion that is actually real, and it's not just the expansion. There's actually inertia present. And that inertia is a force internal to the system of the electron itself. I didn't throw away classical mechanics. You know, it's still in there. My version of expansion theory and Marx's version. So, more of this. Mass is resistance to transformation. When two electrons collide, just like two billiard balls in a perfect frictionless environment, the collision becomes a transformation of vector motion, as is understood in basic physics courses in college. By transformation, I mean that motion of one billiard ball or electron is imparted to the other, and vice versa upon impact, through an instantaneous exchange of force, which we all call energy. While in the real world, the idea of energy or force outside the electron is irrelevant, also true, remember the electron is still the basis of everything, to the final motion of these two electrons, while in the real world the idea of energy or force outside the electron is irrelevant to the final motion of these two electrons, which is after the impact happens. Internally to that transformation, both force and energy are valid measurements. That's why our measurements work, because internally they're measuring these vibrations that are happening, and they all happen to relate to everything because everything's connected. So it's just obvious. All our physics constants should confirm this relationship in that we are all measuring the same things and that those things are all valid properties of the system of transformation of motion through the sole carrier of motion, the electron, whose expansion maintains the properties of the system of vibration itself. Okay? Every time we have an event where two electrons, two objects collide, because that's what all events are, that system is what all physics measurements are made to measure. They are measuring the transformations, changes of properties of the electron, derivative properties that are caused by the fact that motion, space, and time didn't go anywhere. They're still real and they still transform. Why must the property of motion exist in the new model? Motion is an inherent property of any object in the universe, made of expanding objects, assuming there is more than one object in the universe. All objects are in relative position to each other. All electrons, hence, are in relative position to each other. Okay? So, if the universe consists of only two electrons, this is the thought experiment, that are expanding, they will eventually impact each other with all of the expansion that has accumulated from their initial position relative to each other when they were created. This is assuming they pop up from nowhere, you know, instantaneously, and suddenly they start expanding towards each other. Force is the impact, energy is the switch over. So that's like two electrons are expanding, they suddenly have a motion towards each other, they strike each other, and then they go back to their original positions, and then they do it again, over and over and over for infinity, because assuming nothing else changes. Thus, when these two impact each other as they must, they will impart the force necessary to return to their original positions, completely unhindered, before another cycle of them approaching each other begins, assuming the expansion rate remains the same. That has to be true based on expansion theory and its dynamics. And it's pretty important to realize when we get to the next slide. It's the system that creates whatever it is. So however electrons are created, even though everything is made of electrons, however they're created, that's what creates new electrons plus whatever else. What's new under the electron? As you can see in that scenario, no new energy or force was created. The entire system contains within it the energy, force, etc. Yet those properties remain a part of the system created by electrons, space, and time, of which expansion only makes the motion itself possible. Okay? So can you follow that? Let's see. I'll give you guys a second to digest that. Okay, so no new energy or force was created from the motion of the electron. The force existed the minute those two particles came into existence. This is hypothetical. I don't think this is exactly the way it works, though in later versions of my theory in the next video, this is just this video, I'll explain my version of how that might work. But essentially, the system has within it those properties, and they'll just exchange the properties forever if there's no new electrons popping in. So it is not to say, if it's two of them, it is not to say that electrons pop into existence from somewhere in such a manner. We don't really know yet where they come from, but it can be said that this particular thought experiment demonstrates that the expansion of the electron doesn't change the absolute condition of the internal energetics of the system, which is created by the expansion itself. The only things that can change that energetic that we know of is the emergence of more electrons from somewhere, or the removal of electrons to somewhere that is outside the physical universe, or this physical universe if you believe in multiple parallel dimensions of physicality of one form or another. So that kind of covers that whole idea. The law of the conservation of distance. If electrons are created in such a manner as described, impact each other in such a manner as described, and return to their original relative position relative to the other electrons, then a property exists in any system made of electrons, whereby the space between two of them is conserved over time, as they have a tendency to return to exactly the same position over time relative to each other, upon which they repeat the cycle. Very complicated idea, but essentially states something along the lines of what Marx states concerning the space inside the atom versus the space outside the atom. So it's kind of like, okay, it's not exactly what Marx is saying, but I essentially state that, okay, no new distance can be created between two electrons, essentially. That conservation of distance is a property of the universe. I don't know exactly how it applies, but it's there with this argument. Anything has to alter their existing relationship, but it can't alter the energetics of the existing relationship, because that process is fixed, which I just showed you. If you leave them there, they'll just forever bounce against each other. There'll be nothing new. So that relationship, that state it represents, can't be changed. So you have to have something else adding to that, but the original relationship never changed. That relative relationship never changes. So that means that there's a distance conservation happening, essentially, within that system. It's a little bit complex. It takes a little bit while to figure this one out, but it's essentially the law of the conservation of distance. As such, the maximum distance between them will never change, unless the property of the expansion rate of the electron itself changes, which would change their absolute relationships to each other, either increasing their maximum distance if the expansion rate increases, or decreasing it if it decreases. This is going to become important, I think, when people really study the physics in depth to the core of what it all means. These type of principles that I've been thinking of, they're going to become really important. And I think it has a lot of applications, but I haven't worked my way through them completely. But essentially, it's the law of conservation of distance between those two electrons in space relative to each other as they are originally if they are only two electrons in the cosmos, hypothetically. So there is something there that can't be altered, but doesn't add to the energetics of anything, because those are all systems relative to the other systems. I'm probably talking way above everyone's head, but it all follows. Just keep thinking about it. Understanding transformation and the conservation of vector motion. Two electrons are two separate systems unless they physically touch. When they physically touch, transformation occurs because electron vibrations are expanding and because vibrations have the property of mass which resists other vibrations. In this, mass is very much like the inertia of a wave. Yet if these vibrations, the expanding electron itself, are identical in nature to the vibrations which move electrons around motion, which they must be, then the vibrations are that which is expanding, so that all vibration is expanding at the same rate as the electrons. Mass is thus the resistant property of the expanding electron to the passage of vibration, through which vector motion is conserved, which we've already talked about. This explains the difference to Mark's concept as best as I can. Mark doesn't deal with any of what I do. It's all just the expanding electron. To hell with motion. Not that I want to make fun of him too much, but it does sound a little bit like he took it a little too far with that. But we're going to have a big debate about this, I'm sure, between the many proponents of the different expansion models, mostly, I assume, between me and Mark's idea. In Mark's concept, the electron expands at an exact rate which, as far as I can tell, is linear. However, he proposes a property, primordial time, which accounts for its strange behavior. Again, he's saying the damn thing expands linearly, like the rate that it expands at remains the same. And it's much, much, much higher than, in his idea, we can even measure or conceive, which to me like violates mathematical laws and laws of logic and principles. And it's like, well, how can we not even measure it? How can we not even observe it? I mean, it doesn't make any sense because everything that's derived from it is measurable. So you can somehow conceive of a way possibly to measure it. But he says no. So in his view, the electron cannot be understood in the manner I just explained in my previous slides. It exists outside the world of physics as we know it, according to him, in this other subatomic physics, he calls it. And inside the atom, we cannot go with normal physics as we know it. I reject the notion just because what the laws of mathematics didn't change, the laws of properties didn't change, the laws of change didn't change, so I'm not convinced. I rejected this idea as being somewhat questionable. The laws of math are no different inside the atom to outside of it. If we are basing the idea of expansion theory on a simple geometric expansion, then we cannot then say that this geometric expansion doesn't apply to the electron itself. Geometric expansions are understandable. Perhaps someone will come along with the idea of supergeometry to explain it. That was kind of a bit of a sarcastic thing. But obviously not in my understanding. Nay, it shan't happen. They might try it because they like to do all kinds of stupid things. Let's not be one of those people. Know the difference. Again, Marx says the electron expands at a linear rate. There is significant evidence that he seems to believe that this rate is possibly the speed of light itself. Source is his book, The Final Theory, and conversations I had with Roland before I made this video. Since he was like, yeah, Marx says basically the thing expands at the speed of light. And then that brings all kinds of problems, some of which Roland discovered when he was analyzing this, saying, wait a minute, Mark, if it's expanding at the speed of light, that means the speed is constantly increasing. And that means light goes the speed of light only for the first second. Then it's double the speed of light and triple the speed of light because those expansions build up. And that's not supported by things that we observe, though we're not even sure about some of our observations. But Roland brought that to my attention. I was like, that's another big problem is that, well, okay, if this expansion rate is at the speed of light, well, then there's Mark's speed right there. And hypothetically, just from that idea alone, that's the expansion rate. You could calculate what Mark's expansion rate is just based on that idea alone. So stuff Mark was saying wasn't adding up in that regards. However, he would probably not, this is Mark, he would probably not use the concept of rate to judge the electron because he believes that the concept of the meter itself is invalid, being valid outside of the atom and not applicable to electrons themselves. You see, this doesn't logically add up to me. I hold that the electron is much easier to understand as expanding at a rate that is accelerated in order to account for the geometrical stability of the universe. This is an accelerated rate, which means the electron has to double every increment of time that's exactly the same. Let's say like the atom doubles every 19 minutes. It's something like that. Maybe the electron's doubling every half of whatever that is, which would be 9.5 minutes. Hypothetically, we don't know yet. If the electron is expanding at a linear rate of any kind, the laws of physics will change gradually, hypothetically, but in most of my thought experiments, the changes would be abrupt, sudden, and highly disruptive to everything. And that's because of that rate thing I was just saying. Let's say you visualize something expanding at a rate of 1,000,000 miles per second. The next second, it suddenly, that rate and that the volume of whatever that object is relative to the rate will change, and that will change the properties of everything. And in most cases that I was thinking of, for some reason it was like always very suddenly. So it can't be a linear rate, because I think a linear rate just declines immediately very quickly. Maybe there's a way of having a linear rate decline slower, but the problem is the volume. It's not necessarily the rate, it's the volume. And this is another one of the issues with Mark's concept, but we'll get into that later. Accelerated expansion versus linear expansion. In accelerated expansion, the laws of physics are conserved, this is again my version, through the notion that the electron doubles in size every exact time interval, which I refer to as the universal time interval UT. The electron's volume V changes at the rate of V equals 2 to the n number of UT, number of universal time intervals, where n equals the number of UTs. So that's an easy equation for you to understand. It's just the volumetric relationship of a doubling, based upon the idea that it doubles every one being the fundamental rate. So if UT is equal to 1, which it isn't obviously, you can't use it as 1, it has to have a unit to it, then you have to then it's going to be 2 to the NUT essentially. Yes, that is correct. I think I might have to modify that equation slightly, but essentially, if I screwed that one up, I could get laughed at by some mathematicians. But essentially, it's the relationship of whatever. It's the relationship of the doubling. I think the only problem is if UT is 1, then if you multiply n times it, it'll always be 1. So I think you have to have a modifier on there of some sort, which I think I dealt with earlier. But whatever, people. You get the general gist of the whole thing. Interestingly enough, Mark's concept of the atom does not have the atom doubling every 19 minutes. No, I'm not correct. Sorry, I just made a dumbass on myself. Hold on. I'm thinking of 0. Never mind. Ignore that stupidity on my part. All right. Long day. I have been talking for an hour and 15 minutes, so I'll excuse myself that way. So yeah, anyway, the 2 NUT stays. Same thing. Interestingly enough, Mark's concept of the atom does not have the atom doubling every 19, does have the atom doubling every 19 minutes. So he has a universal time interval for the atom, which is interesting. This again is the basis of gravity in his version. Attempting any sort of linear expansion with the electron using the normal laws of mathematics results in the weakening of the strength that holds together everything, including gravity. This is because the size of the electron relative to the expansion speed at its surface would drop off with time, and also the volume would be off, and hence reduce the strength of any derivative properties that hold things together. If the expansion is accelerated, though, this problem goes away. If you try to solve this another way through Mark's idea, you'll run into an even bigger problem. Let's say you say, well, the electron's volume is much larger than it suggests, which is, I suppose, the only argument that could save the theory. Hypothetically, would be, oh well, what happens if the actual volume of the thing is much larger than the volume of the thing? And then you've got yourself a real brain ache trying to figure out, well, how can something be tinier than the speed of light indicates and remain the same size? You're like, what? The thing expanded at the speed of light? How come it's not the size of the star yet? So anyway, so yes, the expansion rate is said to be high, very high, but again, if you look at it from a volumetric point of view, that's where you get into some real brain-teasing issues. And maybe, I haven't done the thought experiment yet, so maybe someone can enlighten me on this. Maybe this is how Mark pulls his theory out in the end, is the idea of, well, okay, well, the electron's volume is massive, gigantic, huge, super gigantic. And because they're all relative to the same size to each other, that means the speed would work because of that. So I just thought of that, so that might hypothetically work in his version of things just off the top of my head, but I think it still probably would introduce some issues. And as you can see, this all will give you all a big headache the more you think about it. But we're going to stick with my model here because I still... Mark's diagram on how light and heat are created as electron clusters. This is right out of his book. This is what light looks like. Clusters being jetted out from the space between the atoms. Light and heat as electron clusters, which are made of electrons, are ejected from the space between atoms by the pressure in an electrical circuit caused by the expansion of the electron and the atom. This is also a probable model in Marx's version of how heat or light is released in chemical reactions, including burning, though some of that might be just the electrons being kicked out from the subatomic realm into the atomic realm and just automatically breaking up into clusters and flying everywhere. Photons are individual electron clusters. Photons are individual electron clusters. That's how we understand photons in the new model. I hope this has been enlightening for you. We're only halfway through, though. Marx's concept of light is that light is composed of a string of electron clusters and a wavelength is the size of the cluster. He states that EM radiation above the mid-terahertz band follows the rule that large electron clusters are close to the mid-terahertz band and small ones are at the top, towards the gamma rays side of the spectrum. So he says, well, I just said it. So according to my research into E equals hv, which is Planck's black body radiation equation, and Max Planck's findings, this cannot be the case if the energy contained in light is directly proportional to the mass of the light in question. Just doesn't work mathematically if you're assuming that a particle gets its energy from speed and mass when it impacts another object. I agree with the idea that the electron cluster, with the idea of the electron clusters, that makes sense, but wavelength doesn't mean anything at all, and I will get into the proof shortly. Wavelength means nothing in my version of the theory. In energy, if energy is proportional to mass in light and other EM radiation above the mid-terahertz band, then the largest electron clusters are on the gamma ray side of the spectrum, and the mass goes up from the mid-terahertz band. Below the mid-terahertz band, in Mark and my concept, what you have are bands of electrons instead of clusters. So this one's real quick and easy. See right here, this is where Mark says this right here is the standard model currently, talking about waves, and this is the two different groups in the new model. Right over here, these are everything below the mid-terahertz band are essentially, they look like this, waves of electrons, and these waves are all made of electrons, little electrons. Try to imagine a circle, please. And then these are the ones that are the clusters, so they're fired in like a line essentially, and it's all cluster here, cluster here, cluster here. So that's the clusters. I'm alleging that the larger clusters are on this end instead of the smaller clusters. Gamma rays, larger clusters are gamma rays, smaller clusters are infrared. Mark's version is the opposite. Larger clusters are infrared, smaller clusters are gamma rays. Assuming that light operates as a stream of mass that is composed of electron clusters moving at the speed of light, then the energy described in E equals hv is precisely the number of electrons passing a point per second or emanating from a source per second, as Planck's constant h is in fact the mass of the electron moving at the speed of light, and when you add the frequency in as the number of electrons per second, that's what I believe the frequency is, as you get an energy as a unit of transformation, just as I described in the new material philosophy section. That is what the energy in the light particle or any other particle, whether it's cosmic ray or otherwise, is, people. It's really easy to understand. This is evident directly from the fact that there is no missing energy really in millions of real-world usages of light to fuel energy devices all over the world, solar panels, etc. The evidence is in fact overwhelming that energy is real and is imparted by the impact of light or any other object in motion whenever it strikes a measurable circuit anywhere in any electronic device. The measurements cannot be denied. This argument is against Marx's contention that motion may not exist. In H, the H in E equals hv is what's stored. The H in E equals hv is what started quantum physics in the first place. It is the quanta. When Max Planck discovered that energy in light could only increase in certain precise increments, he called quanta. Mark himself states that this quanta was Mach's discovery of the electron. Wavelength is invalid Then because it is precisely the speed of light divided by v. It is precisely the speed of light divided by the frequency, and thus the exact size of one electron. So that can't be Mark's wavelength or anyone else's wavelength, really, though it depends, possibly. Oops, sorry. By this very definition, assuming the very definition given by Mark. So if you read that whole thing again through, give me a second to breathe. Whew, should get some water here or something. All right. As such, clusters must have a different size to the wavelength as described, unless they don't exist at all. I'm willing to consider the possibility that the clusters aren't real and that every string of electron is one electron in size, but I still like the cluster idea a lot, even if they don't directly relate to the wavelength. However, as a mechanism preserving the idea of the photon from our current physics, the electron cluster may be correct. So neutral-ish. I kind of like the cluster idea, but it's not really a scientific reason. I suppose I should say 50-50 on that one, but it doesn't change a hell of a lot. I tend to see the necessity for the cluster in terms of preserving the solid beam theory of light and upper band EM radiation. That's probably the best argument for it from what I've thought of, which means that the light is a solid beam going from its source to you. It is a solid bridge of matter in the form of clusters, or possibly one electron, though I tend not to believe that it's only one electron, one after the other. Though it might be, but that creates probably problems somewhere in the theory. I think. Yeah, I would say that the electrons' relative sizes would be different. But that might be true as well, but it's still technically a solid beam. So we'll discuss the next 100 years plus. Mark states that light passing through glass slowing down and then speeding up, which is a known physics experiment, when it leaves the glass proves that electron expands readily in the space outside the atom. Again, Mark is using that the subatomic XS expansion rate of the electron to explain why light moves at the speed of light and from its point of emanation, not absolutely, and why light just suddenly appears, I guess, when there's an explosion or some kind of instability, which again has, I forgot to mention the proof that cosmic rays, like he says, protons, neutrons, when you strip them from the electron clouds in the atom, they automatically convert to light, but cosmic rays are an example where that is totally false. Cosmic rays are not surrounded by electrons, but they zip through space as ions without electron clouds. They don't change into light. They stay as the mass we know them, which is probably one of the biggest arguments against Mark's conversion theory, that like any atom or any nucleus removed from an electron cloud will suddenly automatically turn into light, as free energy. I mean, if it worked, yeah, great, we could get all this free energy, but I just don't think so. And I really think the proof overwhelmingly will show that that's not the case. So again, that's one example, but also whenever we make plasmas, plasma physics, you can get ions that are basically stripped of electrons, more or less, even though they're kind of still in an electron soup in that case. So that one's not quite as strong a proof as cosmic rays that are zipping through the middle of space where there's hardly anything. Or if there's magnetic fields, they're exceptionally weak. So it's barely an argument to say, well, why didn't they change into light? Because the particles that changed into light had stronger magnetic fields around them, that they changed into light in this hypothesis. Anyway, so my interpretation is that light slows down when it's passing through glass. Again, we just did the glass experiments. He says electrons slow down passing, the light slows down passing through a medium. And then the speeding up again is caused by its just returning to that external atomic expansion rate. That inner expansion rate. Well, I say this is my interpretation. Since he was using that as one of his major proofs that that's exactly what happened. So my interpretation is that light slows down when it's passing through glass or a different medium because it has to pass through more space. And this makes sense. As it bounces around different nucleuses and atomic electron clouds, so that when it leaves the dense medium, it resumes the speed of light because there is nothing slowing it down by requiring a longer path any longer. So I say All right, Mark, this is my answer to your idea. Well, the reason it speeds up again is because that's automatically what the light does. I say it's because light's going through and having to take a longer path to get through there. And then because there's still electrons behind it, it's a beam of light. Those electrons in that light, the electron clusters in that light beam, are pushing them out too. So there's not only it's not only one effect, it's like two effects for me. It's like the first effect is that once they're clear, they'll automatically keep going at the normal speed because there's no more path for them to have to bounce around. So you're not seeing a reduction of energy, you're seeing a reduction in the speed or reduction in the motion in this case. You're seeing a reduction, an increase in the length of space that has to be moved between. So there might incidentally also be a decrease in the speed when it comes out the other side, slightly, which is part of the redshift counter argument to the Big Bang now that we'll get to when we get to that in the next video. It is the solid beam theory of light that applies here as a solid beam, again, representing mass pushing on mass, forcing the very first photon photon/electron clusters in the beam forward by the inertia of the beam made of expanding electron clusters going all the way back to the source of the emanation of the light beam, which is what I just said. That not only are they clear of the space, but they're also still being pushed from behind by all these other electron clusters all the way back to the original source. So you're literally looking at a solid beam of force that's being shoved through. That's a very different way of looking at light. Now light is like, it's a solid structure. It's no longer just, oh, it's a beam. No, it's physical. It's a physical structure going right from source to sink, to the very tip. All right. So this is another one of Mark's arguments to try to prove that the clusters are larger on the red side as opposed to the violet side, which is the opposite of what I think. Mark states that because red light bends least, this is actually a good argument, it clearly has much larger electron clusters than violet light and thus has the largest electron clusters due to its mass or density. This one threw me for a couple of minutes while I was like, oh shit, that one's good. But essentially he says, okay, well, that's the reason that red light's over here, is that, oh, it's obviously much more massive, so it's able to just plow its way through. It's not been bent as much from this point here because it's much more massive, But then the counter argument is actually the one I just made for the last slide. I believe that the size of the larger clusters of violet light force it to take a longer path through the prism because its larger size will strike more nuclei and electron clouds. And I think, again, that's all actually really happening right at that point, is when they first impact. There's a very clear deflection caused by essentially the differential. And I think that when people look through it carefully, they'll see, oh, okay, that's why it's taking this longer path through the object on that grounds. It's just the transformation that happens right at that point. Then they also happen to take a longer path through the object. So I think there's a combination of things going on there, but it's mostly what I'm saying here is that basically it's just the essential path that they would take because of their relation. And the proof for that is that they have to find that perfect angle to make the spectrum come out. It can't be done it has to be hit upwards like the way it's shown. It's got to come up this way and then hit it going up this way. And my physics brain isn't strong enough to say, okay, well, can he explain that as beside the idea of the longer path? Because the longer path is a valid argument, but there's something that happens just in that exact spot. Maybe it has to do with the amount of nuclei involved, where this should technically be slightly scattered, but the way it comes out like this, they're all clearly defined. So if it was just this, if it was just this argument here, that they're going to take the longest path, you still kind of expect there be a mix of red and blue and orange everywhere. So I think this maybe it has to do with mass statistical problem, because the amount of atoms that get hit here are sextillions and more than that probably. So this is actually the combination of trillions of events that actually bring it out to this exact result. I think that's part of the argument. I think there's also something going on at that point of inflection because it has to be perfect in order for this to come out. But I'm pretty sure with those two, the combination of those two ideas is what's actually going on, and that red is still a smaller cluster than violet because the energetics can't be. I'm going to have a sore throat tomorrow. Good God. So yes, I wanted to say thank you to Mark. Thanks, Mark. We love your book. His examples on gravity are so goddamn awesome. I can never complete the proofs the way Mark has. I'm a faster thinker than him, but he's like more thorough and logical at times. Like I kind of like, I'm one of these way seer type of minds where I get the answer and then I have to work my way back to give the explanation half the time. Sometimes I'll find a hole and I'll toss the idea, of course, but like my mind works sometimes a little faster. But the logic, Mark's mind is more construed to make logical, slow arguments. Like this for me is like a struggle. Like for him, I think it would be easy for him to write the way his book is so clear with such great presentation. But because my ideas here, they're presented in sequence and with the right information there. But I think sometimes people are going to struggle with the way I convey some of the information because it takes a while to actually get it. But anyway, thanks to Mark. Like I said, if there's ever an international science community that wants to give someone a Nobel Prize, I would like one, kind of ish. If we both get it, that'd be great. But I think Mark deserves it slightly more than me because his original concept was what started this whole thing. Though karmically, I'll hold you all accountable if you don't add me with him, and I happen to be right about most of what I write about, if not all of it. It's probably most. I'm probably not right about every single thing here. But in any case, and like I said, I think Mark's a genius, and his solution with the expansion pressure is awesome, and I happen to agree with him about everything except this Planck constant stuff and some of the light experiments and some of the atomic stuff, like the atomic expansion constructs. But I still think he's the father. He's the father of expansion theory. I am just the distant uncle of it. No, just kidding. I'm I'm the number two guy, I guess. I am the Schrodinger to the Einstein. So Mark's the Einstein. I'm the guy who's coming in to mop up and this. I'm sick of it too. God, I want to get this over with so I can move on to something else. Oh my God, I didn't do that correctly. That should be 10 to minus 51 there. Is it 10 to 51 kilograms? What the hell? Oh God. Oh, can I correct that? Can I correct that? Oh, yes, I can. Okay, no problem. No problem. I can correct it. The column is perhaps the most interesting unit. Okay, so I'm going to move on to the analysis of equations and physics constants for you physics people. You're probably sick of listening to me blabber about these like basics. They're like, where's the meat, man? The column is perhaps the most interesting unit of the standard physics model to analyze in the new theory, as it is said to be the unit of fundamental charge in current physics. Since charge doesn't exist, what is it then? The most likely possibility is that the column is a unit of mass made of 6.624 times 10 to the 18th of the semi-stable particle that is made of electrons that current physicists call the electron, but is in fact just another subatomic size particle that is actually akin to an electron cluster. This particle is far larger than the estimated actual mass of the electron based on an analysis of Planck's constant, a mass that comes out to approximately 6.3622 times 10 to the 51st kilograms, 10 to the negative 51st kilograms, excuse me. The particle thus is made of approximately 1.2373 times 10 to the 20th electrons. So an electron that we measure in physics is actually made of 123, I think it's quintillion electrons. But 1.2373 times 10 to the 20th electrons actually makes up what we call an electron in particle physics. All, of course, had your minds blown by that, but let's move on. It's true. It's absolutely the truth. You just look at the math, people. Look at the math. It cannot lie. The column is an important part of several key physics equations and SI units. Very important SI units. If you guys are working with a new theory, understand your SI units. Understand what the properties of physics are. They are waves, vibrations, and transformation. The ampere is the fundamental unit of current. We use it in electrical engineering and is expressed as coulombs per second. C coulombs per second, C over S. The coulomb is as an SI unit part of the volt, the fundamental unit of electromotive force, the ohm, the fundamental unit of electrical resistance. So the volt is the fundamental unit of electromotive force, the ohm, the fundamental unit of electrical resistance, the Weber, the fundamental unit of magnetic flux, and the Tesla, the fundamental unit of magnetic flux density. The coulomb is part of all of those. So the coulomb is something that has a basis in reality because it is essentially a unit of mass. Whether it's actually made of these electrons, the particle physics electrons, as opposed to the actual electrons, the fundamental electron, is not a question I can answer quite yet. But I suppose either will do and either will do, because it's the overall energetics of any particular instant that matters. So if the amount happens to be close, half an electron difference in 10 to the 20th, or however many, 10 to the 19th, I think was the column, is not going to make a difference that much. When it appears in these SI units, it appears as the ampere. Right? So all these units here, the ones that I just talked about, the ampere is what's in them when you actually break them down into what the SI unit is from the known physical constructs. Constants, excuse me. It's difficult to keep this up. Okay, so when it appears in these SI units, it appears as the ampere, the unit of current, which in our interpretation, this is Marx and mine, is mass per unit of time, which is very much like a flow. Marx's idea of current is like the flow in a water hose, and his idea of voltage is like the pressure in the hose. I think this analogy is totally correct based on the idea of the column as mass. This is pretty much, basically it's just like a river. It's flowing. The electron's expansion is only providing the structure that allows that flow to occur. The flow is a flow of motion, and the electrons are the carrier of it. All of your SI units are measurements of how a river works. Shortly. Coulomb's law, this is Coulomb's equation right here, is force is equal to Coulomb's constant times Q1, Q2, which are also coulombs of two point charges, I believe is how they refer to it. So this also disproves the quantum physics here. And this is a square of the distance. The square of the distance between 2 points charges, the force of that, and this is a very important thing in quantum physics, one of the primary elements of quantum physics here, is essentially represented by Coulomb's constant multiplied times the force of the first charge, the second charge, divided by the square of the distance, which is a very well-known law. It's also, incidentally, very similar to the gravitational law of Newton. So this law governs the attraction and repulsive forces as currently interpreted between two quote-unquote point charges. And K sub E is Coulomb's constant, which is 9 times 10 to the 9th Newton meters squared over coulombs squared. So again, anytime you see these SI units, I want you people who are thinkers to start saying, what the hell is going on? Relate all the ideas to all the other ideas until you understand every single property that you've seen and whether it's a real property or not. Can we deny Coulomb's law? We can't use it to support the idea of weird quantum physics particles, I'm quite sure. But we're going to get to that shortly. So, while attempted mathematical explanations of charge such as Coulomb's law exist in the quantum paradigm, and this is Marx and my argument against the quantum paradigm, again, we've returned to quantum physics, they cannot be seen as proof of underlying physical mechanisms of charge. Charge is thrown out. So what is Q then? Q is, again, it's a mass. I just told you. Q is a mass. Q is equal to so many electron masses. Without a physical mechanism as an explanation, a charge is just a form of magic that has no basis in observation. You don't need it. You already have force and energy and all of that inside the electrical circuits, and you know that from being electrical engineers. Anyone who's an electrical engineer is probably having a kick about this right now, and people who have studied the electrical universe model are really probably understanding stuff quite very well. As such, Coulomb's law, which is used in electrical engineering, must be properly interpreted to be the relationship between two regions within a circuit, one of high internal pressure of a river of electrons and one of low internal pressure. Source the sink, people. Where's the pushing coming from in the circuit, and where's the pushing going to? That's what you're looking at, Q1, Q2. Inside a circuit, not between two circuits, between two areas that are forcing pressure outwards, like two generators, as I'm going to show shortly. That's where you get Q1, Q2 having a repulsive force. But again, there's no charge, it's just the pressure, and we'll show that shortly. When applied to two repulsive fields, it is the meeting of two rivers of electrons that have two separate poles of outgoing pressure moving outwards from two separate generators of pressure and meeting together, repulsing each other, as you would expect. Resist. Generators and power plants are classical representations of the idea of a so-called point charge in this analysis. No charge, just pressure. Generators and power plants generate force inside an electrical circuit by the force applied against metal wires, usually copper, through the movement of a magnetic field. Think of magnetic flux, how it's applied in your electrical engineering systems. How do we move electricity in a wire? We use magnets. We use the property of induction. We move magnets around with turbines. Those magnets, as they move, they are forcing with pressure, physical pressure, and they are literally pushing it all along. There's no charge, man. It's just force. Force, and that is a flow that's coming out of those generators. A generator and power plant does this by movement. It is all movement. It is all physical. And the application of the physical force is done by the physical force that turns the generator, and by the physical force applied by the physical magnetic fields, which are in the magnets that are surrounding the copper wires in the generator, in the metal wires of the electrical grid, which anyone who knows electrical engineering knows this already, but basically the magnets are moved around inside the generator, and they literally push the electrons, and these copper wires are all coiled up in there, so I assume they provide the most area through which the magnetic force can be applied as a force, and that's how you get energy coming through the wire, force coming through the wire as electrons, as the current, amperes. And the voltage, as you'll see shortly, is essentially the amount of force that's being applied against the current, which is essentially the amount of electrons flowing through. And this is also something that Mark stated. I just went into a little more detail here for people who aren't electrical engineers. Yet all of these generators and power plants are in fact positive. They're not, there's no negative point in the, if we look back at Coulomb's law, those Q1, Q2, there's nothing negative charge about them. They're just relative dynamics. You see, there's no charge involved. There is no charge. And the only thing that can be altered in alternating current is whether or not a flow exists at any particular time, which is true. Like they're basically pulses. Alternating current is essentially a pulse of pressure flowing through a wire. Here comes the here, which basically shows you this is literally what it is. This is the best diagram you can use to understand what is a current inside a wire. That water in there is the electrons, and I'm going to just read here because I'm getting tired. This real-world example demonstrates the actual relationships in AC current, showing you pressure and how it works. The generator creates pressure in the circuit. It flows from either direction. See, it goes either way, but energy is delivered all the same because you're not getting the energy from the direction it's flowing. So Q1, Q2, who cares? You're getting the energy from the force that's being projected from this thing, which is shoving. See, so that's energy. It goes right here. Energy goes right there. Either way, that energy is getting into whatever is connected here. The force of the generator moves the electrons through the system. And I assume that they do have to structure things correctly so that they don't burn out when you're connecting to an AC circuit. Now, I'm not an electrical engineer by profession. My dad was. So this is your guys' expertise, and that's kind of where my expertise ends. But this is basically the energetics of the system. The current in the circuit is in fact the flow of liquid in the amount of electrons. The flow, okay, The flow of the liquid, it's more or less a liquid, the amount of electrons. The voltage in the circuit is based on the speed and size of the generator right here, and of course here by extension. It is the pressure that is being applied to the current. See, so if this little thing starts speeding up, you know, that's more voltage. If you increase the size of this whole container here, same thing. You have to increase the mechanisms too. That's the voltage. That's the, because like, you know, I assume that most of what matters is the size of whatever that particular part of the circuit is. But you get the general idea. The energy of the circuit is the force it exerts upon anything that connects it. That's what energy is. There's your energy only matters when you've connected something, or then there's another impact. That's when you get that transformation happening. Kablow. Transformation. Next. Rydberg's constant. We're in heavy quantum physics now, and this is one of the core ideas of quantum physics. It's called Rydberg's constant. It was discovered right at the beginning of the quantum physics ideas, what we generally traditionally relate as true quantum physics, which really begins with Niels Bohr. In 1885, a Swedish mathematics teacher by the name of Johann Balmer discovered one of the major cornerstones of physics, the Rydberg constant. Using pure statistics and mathematical analysis, Balmer discovered that the light emanating from a hydrogen atom invariably followed a precise law whereby one could predict the frequency of light being put out by hydrogen in various bandwidths of electromagnetism, EM, mostly in the infrared, visible, and ultraviolet range. This is all proven through experiments later as being totally verified. It was Balmer's key discovery that later led Niels Bohr to his Bohr model of the atom, because he created an equation which derived the Rydberg constant nearly perfectly. Based on pure statistics and mathematics, Balmer, which is right here, this is our Rydberg constant. Rydberg's constant in physics and the new in quantum physics and the new physics. Very important little thing here, Rydberg, because of this equation, this fundamental equation right here. Very important equation. Rydberg's constant, as discovered by Balmer, is precisely 3.2916 times 10 to the 15 cycles per second, as related to the frequency of light of a hydrogen atom that is magnetically in a magnetically unaltered state, because there's other properties that relate to this, as I'll describe shortly. Since we should by know in the new theory that the idea of frequency, this is a frequency here, and it's relating to light, so it is in fact a frequency as I'm describing it, means number of electrons per second passing a point per second with regard to the number of electrons in light or other upper band EM radiation. This is not cycles per second. This is electrons per second. It follows that each jump in the formula involves the increase in numbers of electrons relative to Rydberg's constant, which is now a number of electrons. This is the formula. Balmer's formula with R as a constant, which was proven experimentally to be accurate, is frequency of light in a hydrogen atom's emissions when it emits light and heat, because some of this is in the infrared range. Sorry, it should be like balls instead of electron clusters. Light in that hydrogen atom spectrum is released in units that are related to this equation. These units, NF squared, N sub F, which means final state squared, initial state squared for the I. These units, NF and NI, were the beginning of what we call quantum numbers. Very core concept of quantum physics, probably the core concept. It is these units around which quantum physics formed. There's some radical stuff here. So if you understand this frequency, which is the frequency of light emissions, Balmer was able to predict which frequency hydrogen would emit at certain regions of the electromagnetic spectrum before they were discovered, using this formula, because he had discovered relationships in the existing ones that had been discovered. And that's how he derived this. It was all statistics. And he said, oh my God, these things only transform around this number here. They're related to this number using this mathematical formula. So he came up with these numbers because that's what we have statisticians for. Proven accurate. And here's the table from the book Introducing Quantum Physics, which is the best book if you want to learn about quantum physics without being a quantum physicist. Pick this book up. It will take you through the entire history of what I'm talking about, actually, in even greater detail. As you can see on the right, Balmer was dead on about the relationship between R and the hydrogen atom. Again, R is Rydberg's constant. And you see the differences are almost insignificant from what he predicted and what were actually true. And this was number 2. So this was the visible light spectrum of hydrogen. The proton seems to create light and other EM radiation in some manner that is related to R. And it has to create it physically. This is where we're going to get back to the expansion theory model. But quantum physicists never could compare because they had no physical explanation of how it worked. So why are these numbers important? Because this is the first quantum number, n. Why is this number exist? Because it still exists. Whether or not quantum physics is right, there's a relationship and it's based on something physical. So this was actually in the same book, Introducing Quantum Physics, and it wasn't applied to this idea. But when I saw this idea, I just had a mind storm, and it was just like, oh my God, here's the solution. It's right in front of me. It's like this, and this is a mathematically perfectly purified way of seeing it. This is definitely what's going on then. I'm not 100% sure, but this is what made the most sense to me based upon the model that Mark and I have come up with for the atom. And the most likely explanation that I came up with is actually revolving around the idea of harmonics. This is one of the concepts of harmonics. This is the wave harmonics within a closed system. And this is something that quantum physicists, I believe, work with this because they're mathematicians. So even though they didn't apply it in this way, I got this idea indirectly from, these images of certain quantum physics ideas. Similar to Louis de Broglie, I'm not sure if I'm pronouncing that right, but he's one of the cornerstone members of the quantum crew. Shown right, this is some of his diagrams. Harmonics internal to an electron cloud is the most mathematically and physically plausible reason for the relationship of Rydberg's constant and why it works in Balmer's formula. And there's probably a lot in this, but this is my going on for some people that want to think about this beyond what I've done, because there's still a lot to discover. Rydberg's constant in electron cloud nodes. So this is the number of nodes in an electron cloud based upon how much the perturbation of the cloud is happening based upon the amount of energy and force that are inside it. So, and then the more perturbation there is, the more number of nodes there are going to be in the cloud. And the number of nodes is probably very mathematically precise, which is what Balmer essentially discovered. So there's definitely a relationship of some sort, I think, to the nodes, especially with regard to that NF final condition in that equation. These first discovered quantum numbers, actually it's only one quantum number, but this is the internal dynamics of that quantum number. When applied to R in Balmer's equation, most probably represents the number of nodes in an electron cloud of hydrogen, just as we see on the right. Nodes represent a precise mathematical and physical relationship in the electron cloud surrounding the proton. Don't forget, hydrogen is just one proton, which is just one particle, representing the amount of perturbation. Implications of this interpretation of Rydberg's constant. Principal quantum number is currently thought to be number of the shell, which is how we understand it in chemistry. As you know, as the shell goes up, you get further and further off the periodic table. Each shell is each line on the periodic table, the main lines. That's how it's currently applied, even though it has absolutely, I wouldn't say absolutely no relationship to that, but it has no physical basis. I don't even know if there's evidence that the Rydberg constant can be applied in any way outside of the hydrogen atom to make any sort of predictions as to what other atoms beside hydrogen what their emission spectrum lines are. I've never heard of any theory that suggests that, unless I'm wrong, but I haven't heard it, so it's kind of weird if I hadn't heard it and somebody had actually worked on it. After all, I do a lot of science reading, though nothing surprises me in some ways in this day. But anyway, the principal quantum numbers currently thought to be the number of the shell, which is the electron shells, and in our current chemistry model, see current periodic table and quantum chemistry orbital models. Around the nucleus represent the amount of pressure in the electron cloud surrounding the nucleus caused by the amount of energy coming in from the environment. Self-explanatory. So the principal quantum number is n, and I said numbers because it's nf and ni, n sub f, n sub I, and they basically are, I'll keep reading here because it's all in here. So anyway, in all likelihood, this only applies to the single proton hydrogen. Again, these quantum numbers apply to hydrogen only, I think. When concerning quantum numbers, as the quantum numbers are all built solely off the actual experimental evidence around the hydrogen atom itself and its EM emission spectrum, which is easy to start because it's just one proton. When you get to the next atom, you're already dealing with four protons and neutrons in a helium, and then you're dealing with more and more. I think it's 7, and then lithium, and then more and more, and it becomes more complicated. So it's easy to figure the proton out, but when you're dealing with more and more particles, it becomes more and more difficult to try to work out what's going on with the emission spectrums, I think. Getting the principal quantum number itself is useless, which is how they try to apply it, but it's useless without the application of Balmer's equation. You can't say, what is this n without the Balmer equation? The Balmer's equation is the context. The components of the principal quantum number nf and ni represent distance from the ideal state indicated by R. Rydberg's constant. That's what I think. I think that's the ideal state. Rydberg constant. It's probably the maximum amount of any type of emission you can get from a hydrogen atom, because literally you can't force the proton to go any faster. You can't expand it any faster than it is already expanding. I believe Ni minus Nf is most likely the number of nodes in an electron cloud of that particular Nf state. So, you get basically up to 5 nodes of each of these. They have measured and having, when you subtract them, that's how you get the nodes, the number of nodes. But then the energy states of the environment are most likely based on these as well. And these kind of represent levels. And again, this is 1 is 1. And then if you do this one's half the energy level of this one. If you look at the Rydberg equation, this one's 1/3 the energy level. Oh, no, sorry, this is this is actually 1/4. I'm sorry. This one's 1/4 because they're actually square. This is 1/9, and this is 1/16 of the level of the first one. So again, these are all fundamental relationships. A geometrical mathematician should be able to figure this out. I'm not going to jump too far into this. You've got enough information. I think that someone else can handle this theory from this part of the theory from here on out, because I'm sick of it. Here, see the table that shows that we would expect the largest and hence most energetic electron clusters are in the ultraviolet band, just as I said. Again, the largest clusters are here, which are closest to the maximal state implied by the Rydberg constant, the highest possible frequency for a normal hydrogen atom. Here's my source for this table. The relationship of the nodes to the idea that Ni minus Nf is the number of nodes is clear in this table as well. Nf expressed as a fraction in Balmer's equation says something as well. Again, someone else needs to work on this. Regarding the electron cloud surrounding the proton. It really does. Nf is also important. There's a fundamental geometrical relationship being described here for people who know expansion theory. You can work it out. It shouldn't be that technically hard, but I'm tired of thinking. So the best guess here is relative distance, which is probably the best one, and possibly fullness of the amount of electrons, because up here you got maybe more electrons because a lot of light has hit these. You got a pretty hot hydrogen atom, which means there's a lot of electron activity going on in that electron cloud. Most likely a lot of light or heat has hit it for a long time, and so all that extra energy and mass built up around it, and that's what's getting it to jettison at near its maximum possible projective force, which again is 1NF, which is related to the Rydberg constant, is the Rydberg constant. So, all right, the expansion theory and the energetics of everything. Final thoughts on the place of quantum physics. I don't totally reject everything in quantum physics, but here we go. Certain ideas represented in quantum physics, especially functional equations, may represent ideas that we should consider in the new model, but only as they relate to the new model structures. So structurally, quantum physics has to be related to the new model of the nucleus, the new model of the atom, all related to the expansion pressure, all related to everything I've just discussed here through either Mark or my version of it. The fact that Bohr derived the Rydberg constant using his complex formula, frequency is equal to that big mess right there that you see, times the Rydberg, that part of the Rydberg constant, may have some application to the properties of the hydrogen atom and proton relative to the electron cloud. They might, because all of that is still part of the existing dynamic of what we know from the constants of physics. The 2 pi squared mq to the 4th divided by h to the 3rd value differs from the measure of r, which is Rydberg constant again, by only a few percent, is calculated to be 3.26 times 10 to the 15 cycles per second, as opposed to 3.29163 times 10 to the 15 cycles per second, which is electrons per second, for Balmer's statistical analysis of actual results. There's a lot to discover, people. The case. Like I said, I'm sick of thinking of it, but there is some answer. Frequency. Again, this is Bohr's derived equation, which was thrown out later in quantum physics, mostly. But because this is Bohr's model with his electron circling the atom like a solar system, which incidentally, just a real quick aside, Roland's theory involves a classical Bohr model with neutrinos, which are his electrons, essentially going around the electron, which is the electron as the particle physics people understand electron, as opposed to the electron that is expanding. Complex things to keep an eye on, but you know they're all in there. His idea is, okay, well maybe there's really an orbital thing going on, and it might be. Maybe there's these big giant, I call them meta electrons, particle physics electrons that are made of 10 to the 20th actual electrons. Maybe they do float around like an orbit still. We don't know yet. We're still in early models of understanding this new atom. So Roland might be onto something with his, well, maybe there really are orbits down there. So anyway, the Bohr equation here uses several fundamental physics values, which are measured and confirmed, including Planck's constant. We know that's the electron moving at the speed of light, that energy that applies to the electron when it is moving at the speed of light. Sorry, I repeated myself. Q is columns, there, Q. Meters, pi squared. Pi relates to both spheres and circles, of which an electron definitely is. So there is some kind of fundamental relationship to the way motion is working with regards to the electron in this equation. I don't have the mind or patience right now to work on it. I could probably figure out, but I'm kind of tired. Like I said, I've been doing this for years and I need a break. Another question concerns angular momentum, which is where, is this maybe some type of angular momentum relationship in the new model? Does the electron have it? Does the electron have angular momentum? I must say that it is highly plausible. I actually like that idea. I don't know if Mark probably won't like that idea too much, but I think it's highly plausible. And it's possible that some of the quantum discoveries, all these equations and relationships they discovered, which they interpreted one way, actually relate to relationships concerning the idea of spin, meaning the individual electron and the amount of energy it has stored as spin. Interestingly enough, more so than any hypothetical system of particle stability relationship, which is what it's used to support nowadays. But I don't know for sure. I don't. Because a lot of thinking to actually be certain about these things. But I know I'm on the right track. I think spin's important. So then there are the last quantum numbers, which have been discovered, K, M, and S. These are all related to different states of hydrogen's emission spectrum. One was K was about hypothetical orbitals that weren't circular or elliptical orbitals. M was magnetic, so when you apply a magnetic field to hydrogen in different directions, you get additional lines, spectrums, and then S is, I'm not really quite clear what it was, but it's related to the Pauli exclusion principle, and it's part of the hybridized orbital theories, as everyone knows, I suspect. Do any of these things mean anything anymore in the new model? We're not sure. They want to accept some of the plausible relationships here. Here, by the way, is the 4 quantum numbers and how they're interpreted. Quantum numbers, complete garbage. I think Mark probably considers them complete garbage. I think that there's a lot to be learned from this, possibly, but not in the way they understand it currently, or hinting something. Why do quantum numbers appear to predict some aspects of the periodic table? They do, but they miss others. Of the periodic table of the elements numerically, but fail in other ways. And they do. They fail to really give a predictive explanation as to why the system is set up the way it is, as it's currently interpreted. K is said to represent elliptical orbits, but of what now? And these are fundamental questions. Elliptical orbits of electrons? Well, okay, why? See, there's is it real or is it not real? Who knows yet? It's almost irrelevant right now, but maybe when we get into the dynamics of actually working with the atom in future chemistry, this stuff will end up being fundamentally important, but it has to be completely reinterpreted if there is anything valid, which I'm not sure about yet. M is supposed to be change hydrogen EM spectrum based on magnetic states, which is correct. S is associated with the weird Pauli exclusion principle, whereby the old electron was said to be consistent of half a spin. What the hell is half a spin anyway? Who the hell thinks of these ideas? Why would it be fixed at half a spin? No one ever explained that to me. I always found Pauli exclusion principle and Heisenberg's principle, which I'm about to bash thoroughly, to be. No matter what the quantum numbers represent, they certainly don't represent proof of the quantum physics paradigm. Despite all the particle collider experiments, nothing has been proven whatsoever despite all the hype. Expansion theory provides all the essentials necessary for what matters in physics, a working theory. A few crumbs of quantum physics post-Balmer, the last worthy idea that I found was Rydberg's constant, that are worth salvaging relate only to a possible construction of a proper expansion pressure-based nuclear model, with protons and neutrons accounted for. And last but not least, how many Higgs bosons does it take to get me out of here? I'm guessing that I'll have to stick with a less exotic form of fuel, since they don't exist. Doh! Why is light emanated at the speed of light? Mark believes that light composed of electron clusters simply returns to its original massive expansion rate, once we discussed before, once outside the boundary of the atom, xs, that's the expansion rate of the electron, in Mark's theory that cannot be determined with conventional measurements in the realm beyond the boundary of the atom. Yet the speed of light is quite measurable, oink oink. That's my sarcastic response. Like I said, I respect Mark, but I couldn't get around the idea of the expansion of the electron outside the atom being massively huge like that. I believe the most likely explanation involves the accelerating power of the proton and or neutron. So again, the question is, why is light emanated at the speed of light? What's the physical explanation for that? So I believe the most likely explanation involves the accelerating power of the proton and or the neutron on any electron clouds near them that happen to have been saturated. That is, they're just overwhelmed with all the extra light, the new electrons that are flowing in through light clusters, or overwhelmed with the amount of energy that's being directed at them through whatever means. I generally believe that the expansion of the proton and or neutron must approach the speed of light. This is kind of a rough new hypothesis for me in terms of the absolute motion, since they are made up of about 2.27 times 10 to the 23rd electrons each for the proton. That's my number derived off of the mass of E equals h from the mass of the of h of the electron from E equals hv. So pretty straightforward with the math there. You can double check that and you'll see it's correct. However, the energy of the motion must come from a source other than the proton and or the neutron's expansion itself, because of the law I mentioned before, the conservation of distance. They would just, if there was nothing else going on, the proton would only accelerate the electron and it would just become another atom. So some other source of motion must be there, because the proton's accelerating all of the electrons that are still in the atom at the same rate. So maybe it has to do with maybe something like stacked acceleration, maybe like electrons expanding between the proton and the electrons that get kicked out. But that speed of light is very, very, very in terms of our physics, and it's exactly the rate at which we know light is emanated, even though there can be different speeds of light in the new theory. Which does change what we call the frequency, but the frequency is again the number of electron clusters passing per second, which changes the color we perceive it at, which is part of the brain, we generally believe. Though I've got other theories about that. I got an essay on that on my website, chrisfreely.com, which goes into some deeper notions than what we're even covering here. So the electron could conceivably store motion as spin for one possibility. Another possibility is that pressurized motion builds up in chemical bonds as electrons get bouncing between the two nuclei. Another possibility relates to the idea that dense electron clouds simply store up the pressurized vector motion through structures of some sort, possibly the large particle that we call the electron by conventional physics. So that structure, again, if you can see any type of pressurized structure where a shell is holding together something, we would ask, well, what could glue the whole thing together? Well, that's part of the questions of the new theory, like what do you see a structure as nowadays? So you can conceive of somehow electrons being trapped inside structures momentarily, building up pressure in a way, and that is kind of the way we have to go when we're thinking about, well, what is causing that light speed emanation from the proton? Again, it seems most likely it has to do with the acceleration of the proton, and that is the explanation that I think fits best, but I'm not certain. It could, again, be any of the other properties that are down there that are causing that. It is also possible that the emanation of light is related to the constant that is built into that very particle that should be called something like the meta-electron. It means the particle physics electron, which is also even more plausible, because the proton is usually in the nucleus with a lot of neutrons, lots of protons and neutrons together. So it's even more plausible in one analysis is, okay, well, maybe that big particle electron is actually just kicking electrons out periodically in some manner that always accelerates them at the speed of light. We can't be 100% sure yet, but there's probably enough evidence at all the collected physics experiments that can probably give us an answer even at this point. The new model of the atom continued. Chemical properties of atoms when they interact to produce chemical reactions must be explained in a new theory. So here goes with that. I'm going to try to rush my way through the rest of this because this is already taking too long. And I'm tired, and my jaw is kind of getting tired. The concepts such as chemical orbitals sp, d, and f have no real function in chemistry as predictive tools. That should say as predictive tools, and must be discarded as such must be useless ideas as hybridized orbitals such as sp3 and so forth. Made some mess of the English there, but you get the general idea. In the place of the old and now useless quantum orbital system, we should introduce a system based on the known observation of physics that can be confirmed. No more sp, df orbitals. You can't really use them. I took chemistry classes There's so many exceptions to these damn things that they have absolutely no application whatsoever. And there's no basis, as far as I can tell, for them. Because, you know, we got bouncing electrons now, people. We don't need these probability orbitals. Measurement of the relative size of atoms and ions produced after chemical reactions offer evidence to what is actually happening in chemical reactions. So measurement of the relative size of atoms and the ions produced after chemical reactions offer evidence as to what is happening in a chemical reaction in the expansion theory model. Have discovered. See over here, electronegative, very small. Very electropositive, if you could call it that, very large, and everything in between. And that's basically related to the size of the nucleus, most likely, in terms of its relative size, not its mass. The size of a standard atomic radii show the relationship between the ability to accept electrons in chemical reactions and the ability to give them. Right? This suggests, based on the understanding of the new theory, that the nucleuses of metals is larger than the nucleuses of reactive nonmetals in terms of the relative space they occupy in the nucleus. Because the nucleuses of metals are larger, they produce more force against the bouncing electron cloud around the nucleus. So these things are under a lot of force. These metal the electron clouds around these metal atoms are under a lot of force, and there's not a lot of force around these nonmetals. When a metal and a nonmetal contact each other, the force of the expanding nuclei of the metal forces electrons out. Get out of here, you bastards. Go in there. Forces them out, literally again like a river, just like an electrical circuit, same basic principle in many ways, out of its electron cloud and into the electron cloud of the nonmetal. So the electrons get kicked out by the force of the nucleus the minute they come into contact with a less forceful electron cloud, perhaps, but they basically just get kicked out into the electron cloud of the nonmetal, whose nucleus is expanding at a much smaller rate. The mass of the nucleus does not always determine its relative size. A very important idea. This is very similar to the way Mark describes the fact you can't know what the mass of a planet or a star is, because Newton's gravitational force does not work the same way that expansion force works. The mass of the nucleus does not always determine its relative size, which is what determines how great a force it exerts on its electron cloud as it expands outwards. This is similar to how Mark states that the mass of the planet in theory does not determine its gravitational outwards growing expansion. That's right, gravity is not based upon the mass, it's not based upon the mass, it's based upon the volume. It is in fact the volume that is the key property when considering this mass. Mark specifically says a styrofoam planet would have the exact same gravity of a pure planet made of pure uranium. However, the nucleuses are structured. The larger size is obviously present for the metals and not the nonmetals, which accounts for the high electronegativity of the reactive nonmetals and their ability to absorb large amounts of electrons. The reason primarily is that their nucleuses do not force electrons away from them as readily due to their relatively smaller sizes. They just don't push them away that easily. That easily. We also see that halogen gases which do not react also have larger sizes. Which is an interesting thing to also consider. I think, people, my jaw's getting sore. Can't keep this up much longer. So do your own thinking a little bit and see if you can put 2 and 2 together with all the clues I've left you. Bonds, bonds, and more bonds. Molecules are held together by the expansion of the nucleuses, which squeeze out electrons upon a bond being formed. The electrons that are thus squeezed out by the pressure become light and heat. That's what we see chemical reactions with light and heat. Covalent bonds retain the linkage between two nuclei through a bridge of electrons, but the expanding nucleus is the true force in chemistry that holds together molecules. In ionic compounds, an electronegative atom is now surrounded by the electrons, which originally came from the metal, which is now an ion as well. Positive ion, negative ion. Quote unquote, positive, negative. Giving ion, receiving ion, maybe. We'll have to rename those. Stronger ionic bonds in complex materials are also often are often found as geological crystals or more akin to proper molecules in many cases, which is very evident by the structures. Proper molecules are those which have covalent bonds. Complex crystals are difficult to break down, and they behave more like covalent bonds because some of them have covalent bonds in them. Fusion, fission, and all that jazz. Mark believes that the energy of a nucleus is liberated upon the surrounding electron clouds being removed automatically, returning to the expansion rate of the electron as he sees it, xs. This explains the sudden explosion of a hydrogen bomb. I believe that motion is stored in the nucleus so that when certain collisions occur, some nucleuses, especially the bigger ones, explode because of the release of trapped motion that is structured very much like pressurized gas or a spring, in a manner that is part of the structure of the nucleus, likely revolving around the way neutrons operate in combination with protons. This makes sense to me anyway. The overview of this process leads us to questions concerning the nature of nuclear fusion and fission and the discrepancies surrounding current astrophysics theories and even many of the assumptions and experiments in current fusion theory itself. That is going to be discussed of our review here. Half-life, ho, 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 I mean half-time overview. All matter is made of electrons which expand. Motion is moved around by electrons and still exists. Motion must be understood to be conserved. Distance in an extended analysis, part of that of philosophy again. Motion is the key property that is stored as energy. That is very important to understand. Chemical, nuclear, and cosmic explosions are all the release of stored motion. The electron carries that motion, but it is stored motion. Dense materials such as nuclei are the best place to store massive amounts of motion in the form of built-up pressure. That's why nuclear energy is so much more powerful than chemical energy. When something disrupts the structure of a nucleus that has too much pressure built into its structure, it explodes violently, releasing that motion in the form of force-projected light, heat, and radioactively unstable nucleuses, which continue that process. Magnetic fields transfer energy into circuits by means of physical force, pushing the electrons inside the wires of the group. Light is made of expanding electrons, most likely in the form of electron clusters, which are balls made of electrons. Smaller subatomic particles that are stable are similarly made of these expanding electrons in large numbers. Light travels at the speed of light when it is emanated from a source, and which is likely caused by the proton and or neutron's expansion or by other ideas suggested earlier. Eventually we'll figure out which one of those is right. Light can in fact change speed based upon passing through substances, since it is a solid stream of electrons which are now solid 3D vibrations and expanding in space. This is important when we deal with the next video and proofs against the Big Bang that deals with redshift and blue shift, and the fact that the energy that is imparted by the relative motion of a star or planet to us, the blue shift, is actually an increase in the speed of those electron clusters relative to us, and actually is an increase of its energy, and may in fact indicate that that light is reaching us at faster than the speed of light. Ooh, fascinating. Sometimes it's speed, sometimes it's other things. Light is very complex in the new theory. You have to think your way through those experiments in order to understand what is happening with any particular redshift or blue shift. There's a lot of variations of that theme. But again, they're all physics, and they obey the laws of physics as we understand it now. Gravity is based on the expansion of the atom, which is made of electrons. Orbits are stable, straight motion. This is one of Mark's primary contentions. Orbits are stable, straight motion. It's a straight motion, linear motion around the expanding object. So the orbits are actually, those objects are really moving in a straight line, and the so-called curvature is actually and you could call it like the shrinkage of space, possibly, even though that's not technically accurate. But essentially, the planet is occupying the space as it expands, and so that's why these straight lines, you can't really call them lines, they're moving in a straight line internally, you could say. If the planet wasn't there, it would be a straight line if there was no planets anywhere. but then that curvature is caused by the expansion of the planet or object in space. So, a few slides ago. What's next in part 2? In the next video, I address the Big Bang and why it never happened. Parts of Mark's ideas and parts of my own, but mostly a mix of what's already been said by a lot of electrical universe people and a few extra ideas to boot. So, or if it did, it isn't even close to what they say. So I'm going to add some other thoughts on that. I think that you can't really discount the possibility of ever an explosion happening in space, kind of like the way they say. But we have to quantify or qualify that entire statement. So I will do that in the next video. And it's very complicated when you first hear it. But anyway, real electrical universe. The electrical universe people, they might hate me a little bit at first, but I've actually supported a lot of their contentions. So they should learn to love me. The fusion model of the star versus the cosmic ray model of the star. So instead of the electrical model, you have the cosmic ray. There's a lot of similarities. And the vast new cosmology, it is hideously vast. It is infinite and hideously vast. Dark quasars are my name for black holes. Tune in for what the difference is. No more infinitely dense points in space-time. No more warping of space-time. Bad, bad, bad Hawking's, bad. All right, no, just kidding. Hawking's did a good job mathematically. But no more black holes. White dwarfs and neutron stars. In the new model, hint, some of them are bigger than you think. Hint, it's the neutron stars. The new interpretations of the Hertzsprung-Russell diagram, which is our diagram of stars and their current relationships in the current model of stellar dynamics and stellar evolution, to account for the whacked out new cosmology. The new interpretations are to account for the whacked out new cosmology. It's so crazy, some people won't be able to handle it. The arrival of hyperdense metals and hyperdense crystal formations in planetary and stellar cores. It's time to make ourselves some lightsabers from those Cadrian crystals. I forgot the exact pronunciation of that. From inside stellar cores. When I saw that on that new Star Wars movie, I was like, shit, man. I am so on to the new science that I've even possibly given a reason for why we might one day discover hyperdense crystals that can be made into lightsabers. I want one for Christmas, damn it. Crazy, but it makes more sense than our current models, and it's more entertaining. A new stellar life cycle that could take many trillions of years to end, up to several hundred trillion, in fact, in some of my mathematical calculations, depending on what variable is what. Don't know for sure, but lots of thinking and lots of fun for future scientists. The new short-term, long-term stellar life cycle model. If you read all this on my core essay, you already know what I'm going to say. But, there's... the long life cycle of a star usually ends when a civilization destroys it or it crashes into another star. That's really the end of its life. The white dwarf or the neutron star or the quote-unquote black hole, which is now the dark quasar, is only a momentary pause in the life cycle of a star that's going to come back to life. So there's no dead stars, which makes everyone happy. No more dead, oh, that poor white dwarf, it's dead. No, it's just quiet and quiescent, perennial, waiting for its chance to expand back into itself. Much to discuss next time. 3 dimensions, possibly based on 4th dimensions. I highly, strongly think so. 4th dimensional property, etheric density that might control expansion pressure. Remember, expansion pressure happens at a rate. That rate could be variable. I think it is variable, since it's crazy to think it's not going to ever vary. Even Mark said, yeah, it probably varies over time too. So I just developed a property that I thought of years ago, 4th dimensional property, etheric density, that by which you could actually modulate the expansion pressure. And that happens naturally, I think, in the universe, that there's actual modulations. And create different new and exotic elements in some parts of the cosmos with different periodic tables. If you've seen any of my previous videos, I mentioned this. The new planetary stellar transformation theory, where planets of sufficient mass can eventually become stars and sometimes vice versa after a nova supernova. Part of the short-term life cycle of stars is that a white dwarf will eventually get a cloud coating. It'll start looking like and in fact be a Jupiter-type planet just with a bigger magnetic field. And you wouldn't really be able to tell which one's which unless you studied this for a long time and found out, oh, well, that planet looks like it's that big, but actually inside there's a hyperdense core, so you don't know what's down there. And if you don't know what's down there, you can't really say how much energy is in any particular system just looking at it from a distance. There's a lot of little things like this, and lots of new things to discover in science, which I think is really great. Magnetic field alchemy and space-age reactor engines. I got several ideas. It's on my core essay, a few of them. Magnetic field alchemy is basically the way in which you change lead to gold or gold to lead using magnetic fields and all kinds of other possible variables, which I think happens in stellar cores naturally. So, and that's it. Well, buckle your seatbelt, Dorothy, because Kansas is going bye-bye. Goodbye to everything you thought you knew about science. We're in a new age of science, and it's going to be a lot more exciting, and everyone's going to love it. And it'll be great. And the next part will go into why I think it'll be fun for a lot of people, especially astronomy people. Anyway, thanks for listening to this insane 2.5 hours. This is Chris Freely, and keep looking up to the stars or something. Support expansion theory. Buy Mark's book, The Final Theory, from Amazon or wherever you get it. Visit my website, chrisfreely.com, or my backup mirror website, chrisfreely.blogspot.com, and read the core essay and the 4 attached essays, which are linked at the bottom. You can also visit Roland Michel Tremblay's website. I'm not sure if I got his name pronounced correctly. TheMarginal.com for even more expansion theory possibilities, including the idea that the atom is shaped like a galaxy and the electron is in fact a solar system in that galaxy. Wild ideas. Subscribe via Patreon as soon as I have it set up to keep me going, because I need money. Money, people, money. All right. Thank you for listening. I hope this has been enlightening for you all.